And it looks like we are live. Welcome, everyone. David F. here, and I am here with my friend Leo Felius. Today, we are going to be doing a response to Dr. Jason Lyle's interview with Standing for Truth. He did that interview today, and boy, that was quite an interview, wasn't it?
Yeah, I only watched about the first half an hour because I was laughing so fucking hard. I couldn't. I just couldn't. I had to leave. I had to go do something else.
Yeah. So anyway, the interview was about an hour and 21 minutes long. The link to the video that we are responding to is in the description below. So with that said, let's get started. Make sure I share my audio. Let's see. I might have to mute myself.
For all those who appreciate the work that we're doing here on Standing for Truth, please hit that subscribe button because we are just getting started.
Okay, guys, looks like we are live, and today we've got a very special guest with us, Dr. Jason Lyle. Dr. Lyle, thanks for giving us your time today for this very important show.
My pleasure.
Dr. Lyle, you have been a tremendous blessing to not only us here at the Standing for Truth Creation Ministry, and not only to our faithful listeners and supporters, but also to countless Christians around the world with your dedication and defense of the faith. God bless you for that, Dr. Lyle.
Well, thank you. I appreciate that.
No problem. As a matter of fact, I wanted to point out your book, Ultimate Proof of Creation, was one of the first books I have ever personally read as a young Earth creationist. And it was actually my wife's first book. Not one of her first books on the topic, but literally her first book. And I know this because it was me who recommended it to her at the time and let her borrow it. So you've been a blessing. And I want to point out that Dr. Lyle has written many other must-read books as well, most of which I personally own. A few of those I'm going to put on screen too for people to see. Taking Back Astronomy, Understanding Genesis, How to Analyze, Interpret, and Defend Scripture, and Discerning Truth. So guys, check those out. We're going to make sure that the links to those books are in the description box. For now, I'm going to hand it over to Matt and give a brief introduction to Dr. Lyle, which Dr. Lyle can then expand upon if you would like to. Matt, the floor is yours.
All right. Well, thanks again for being here, Dr. Lyle. Correct me if I'm wrong on any of this, but Dr. Lyle, you graduated from summa cum laude from Ohio Wesleyan University, where you double majored in physics and astronomy and minored in mathematics. He also graduated work at the University of Colorado, where he earned his master's degree and PhD in astrophysics. While there, Dr. Lyle used the SOHO spacecraft to investigate motions of the surface of the sun while looking at solar magnetism and subsurface weather. His thesis was entitled Probing the Dynamics of Solar Supergranulation and its Interactions with Magnetism. He has also authored a number of papers in both secular and creational literature. So I hope I got all that good. And okay, awesome. Not sure how long we have you today, so why don't we just jump right into the discussion?
Okay.
Okay, great. Before we get into the science, though, that confirms biblical creation, I think the best question to start off this entire interview with would be, is Genesis 1 through 11 actual history?
Yeah, it better be. All the other books of the Bible refer to it as literal history. Jesus Christ is descended from Adam. You can read the genealogies there in Matthew and in Luke. And I think it's the one in Luke that goes all the way back to Adam. So yeah, it's real history. The way it's written too, it makes frequent use of what's called the Vav consecutive, and that's where you have and this happened and that happened and that happened. It sounds kind of weird in English, but and followed by a verb in the original Hebrew word order. When you have a sequence of that, that's always indicative of literal history. So there's no doubt. And frankly, Genesis 2:4, where it says, these are the generations of heaven and earth. These are the birthings or the origins of heaven and earth. It's telling you that this is history. This is how the universe began. and how it came to be the way it is today. So creation, the flood that occurred at the time of Noah, Peter alludes back to that as real history. It's something that happened, and it foreshadows the coming judgment by fire. So of course, yeah, it's all real history, and it's theologically important that it's real history because it's in Genesis where we learn that death's the penalty for sin. That death came into the world as a result of Adam's sin. And if that's not real history, then why did Jesus have to die on the cross? So you see the gospel message even goes back to the literal history of Genesis.
Yeah,
Alright.
I just wanted to point out here that literally there's very, 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 very little historical accuracy in the Bible. Like it's literally, it's not even up for
Yeah.
debate. You can go to any academic institution on the planet, go to the history or the archaeology department, and they'll tell you the same thing. Like this is well known within the realm of academia. This is well known amongst academic scholars. The Bible is pretty
Alright,
much 99%
exactly.
bullshit.
Yeah, exactly. The Bible gets pretty much everything wrong that can be tested and can be demonstrated to be wrong. I mean, the Bible is not off to a pretty good start.
No, not at all.
And that being said, I will say that there are different interpretations of Genesis 1, whether it is literal or not. That to me isn't really the big issue. That being said, I will have to agree that I think the only intellectually honest way of interpreting the Bible is through a hyperliteral interpretation of Genesis 1. That being said, I really don't have much of a horse in the race of the interpretation or whatever. But the important thing is that the Bible actually does make a testable claim about the origins of the universe and what we should expect and what we should see. And what we see is contradicts everything that is written in Genesis 1. So let's continue.
Genesis.
Awesome. Great answer, Dr. Lyle. I just wanted to point out a couple super chats that came in. Modern day debate. Thanks for coming on, Dr. Lyle. Really cool. So everybody's excited. Great answer, Dr. Lyle. My next question would be, and it's an exciting one, and I believe will lead into some solid follow-up questions and discussions. What would you say are some of the best lines of evidence against an old universe and for a young one, Dr. Lyle?
The best ones, we have the birth certificate of the universe. The Bible is a history book that records.
So the first evidence is the Bible. God said it. So
Yeah,
not
I
off
found
to
that
a
funny.
good start. Not off to a good start.
Well, yeah, the first piece of evidence is what the Bible says. Like, I literally broke out laughing in real life when I heard this part. I was just like, this is insane.
Yeah,
This
like
is absolutely insane.
I really hope Christians understand this. The Bible is not evidence. The Bible is a claim. The Bible is not evidence for the claim. All claims have to be provided with evidence. The Bible is not evidence.
Oh, and also for all of our viewers, I want to pose a somewhat of a question to you guys, and then at the end of this, feel free to answer either in the live chat or in the comments for anybody that might view this after it's live. So Dr. Jason Lyle is a PhD astrophysicist. As this video goes on, I want you to tell me if A, he's just blatantly and obviously lying about everything that he's saying. He knows that it's wrong. He knows that it's false, and he's just lying by pandering to an audience that he knows doesn't have the technical knowledge to know that he's lying. Or B, that he is truly that incompetent in his own field. Which one do you think it is? I know which one I think it is.
Yeah. Oh, yeah. Given the fact that he does have an impressive PhD in graduate medical law, I think he is lying. I think he is a liar, like Dr. Andrew Snelling. And I'm sorry, but if I know this and he doesn't, then that means he's probably lying. So, yeah, he is definitely not off to a good start. Let's go.
When the universe began. In the beginning, God created the heaven and the earth. Human beings are made on the sixth day, and from adding up those genealogies and so we get so-and-so. You find that it's about 4,000 years between Adam and Christ's earthly ministry, which was about 2,000 years ago. So something like 6,000 years. That's the best evidence because it's recorded history. Now, I think there are...
Again, I just wanted to reach out and just know the Bible is not evidence. The Bible is not a birth certificate. And oh my God, he's not off to a good start.
The only thing the Bible is evidence for is a bunch of really, really old desert folk wrote down a bunch of fairy stories thousands of years ago. That's it. That's literally it.
Yep. All right, let's continue.
lines of scientific evidence that confirm that history, that confirm a recent time scale. But that's the best because it's history, right? I mean, if you want to find out when the last World War happened, you read a history book. You don't do a science experiment and mix chemicals. It might confirm that, but the best way to answer a history question is with a history book. That being said, I think there are a lot of lines of evidence that confirm that. Lots of stuff in space. That's, of course, my area of expertise. There are things that can't last billions of years. Comets, for example, they can't last even millions of years, really, because a comet is made up of ice and dirt, and it orbits the sun in an elliptical path. And when it comes close to the sun, that icy material is blasted out into space.
Can we pause it here quick? One thing I wanted to say is that the first thing he goes to are comets, which some can last millions of years. Many of them don't. He is correct here. But what about stars, planets, white dwarfs, neutron stars, black holes, galaxies?
Yeah,
all the other things in space that last billions upon billions of years.
Yeah, and I just wanted to add on to that. Actually, black holes and low mass stars, they can actually last trillions of years, if not longer. Let me plug in my computer real quick. And also regarding these short-term comets, we do know that not all comets originated in this solar system. And we do know, of course, that most of these short-term comets can also come from the Kuiper Belt and the Oort cloud. Mm-hmm. So again, this is not news. This isn't any this isn't a problem whatsoever. Workday wants a link, so I will send Workday a link. Actually, I'll just put it in the comments. Workday, feel free to come in. And we know that Kuiper Belt exists. We know that the Oort cloud exists. That's not a problem. Anything you want to add on that?
No, not at least not right now.
All right. I'm just going to wait a couple seconds for Workday to jump in so I can add him. Anyway.
That's what forms a comet's tail. We had a really nice one this last summer, actually. I hope you got to see it. Nice naked eye comet. It was very beautiful. But every time you see a comet, it's getting smaller. It's losing mass. We can calculate the amount of material that's there. We can calculate the rate at which it's being depleted. They can't last millions of years. 100,000 years maximum for a typical comet. In fact, in my doctoral research, I used the SOHO spacecraft, and it looks right at the sun. And one of the instruments on it blocks the sun and looks at things that get real close to the sun, like comets. And I've seen comets that have gone behind the sun and been totally destroyed in one pass. So they don't last millions of years. And my secular colleagues don't even dispute that. They would say that there must be some kind of source of new comets. They call them Oort cloud. There's no evidence for that in our solar system in terms of observational evidence.
So I like how he qualified it with
the rate at which magnetic fields decay.
I like how he qualified that with observational evidence. I mean, there's indirect observational evidence, mainly from the fact that the periods of the comets, of these comets, there are many that are much longer than Pluto's, but they're still bound to the solar system, which means they must originate from something beyond Pluto. I mean, we've all the simulations we can run on the formation of the solar system suggest there should be an Oort cloud. We've observed it in other solar systems suggesting it should be there. There isn't any reason to suspect that it's not there. So, he qualified it with there's no direct observational evidence, which is by all rights true. But it seems to me that he's trying to get at this idea that there might not actually be an Oort cloud when no relevant academic professional would agree with that statement.
Yeah, and simply put, it is too far out there for the sun. It's very difficult just trying to find the asteroids in the asteroid belt, let alone all the asteroids in the Kuiper Belt and the Oort cloud. Mm-hmm. And so yeah, that is not any thing to worry about there. And his next piece of evidence is the magnetic field. Let's just play this till the end of his statement real quick.
Magnetic fields don't last millions of years. Magnetic fields are caused by electrical current in the core of a planet like the Earth, and that has been decaying. We know Earth's magnetic field's been decaying. We've been able to measure it for the last almost 2 centuries. It's definitely decaying. It seems to be an exponential decay, which is what we would expect on first principles. It's not oscillating, not today anyway. It might have during the flood, but Other planets as well, there's evidence that Mercury's magnetic field's decaying. Jupiter has an enormous magnetic field. They don't last millions of years. With Earth's magnetic field, based on the current rate of exponential decay, you run it back 60,000 years ago, it would have been stronger than a neutron star, which is enough to rip the atoms of your body apart. And so it can't be anywhere near that old. It's not even a million years. It can't be anywhere near that old.
All right, let's stop right there. We do know that the magnetic field does go back and forth, and we also know from geology, and Jorge can confirm this since he's a geophysicist, that the Earth's magnetic field has actually reversed over 170 times in the Earth's history. And we can look at that quite easily. And Jorge, do you have anything to add on that?
Yeah, what he's saying there is astutely wrong. This is what I did my graduate work on, was exactly magnetic field decay. And, you know, he when he says that in the past it's got stronger, we know that's wrong because old rocks are not stronger. Even the modern day-to-day magnetic field has in no way, shape, or form linear or exponential. It's random. There isn't any direct, like, that's like looking at a graph for 5 seconds and extrapolating an entire field of research by looking at the graph. It's commonly stupidly that's the personal one to me when they bring up the magnetic field. And you're exactly right, Neff, with what you said. And of course, we can also go to comets and other planets and stuff like that. And yeah, all this stuff is baloney.
Yeah, and the thing is that a magnetic field decays when it's not being continually sustained. The magnetic field of the Earth and many other planets are continually sustained by the magnetohydrodynamic effects occurring with the ionized molten iron and nickel in the core of the Earth. Just like, I mean, and this stuff isn't hard. Go into a foundry and ask them how they melt metal with an induction furnace. It's essentially the same thing. As long as that furnace is running, you're going to be creating an electromagnetic field. It's not, you could leave the furnace running for 1,000,000 years. If it's running at the same rate, the strength of the magnetic field will not change because it is being continually sustained. Same basic principle. And by the way, I've worked in foundries, 2 of them. Electrodynamics isn't something that's new to me.
Yeah, also, I want to kind of share this real quick. That's one of the limitations why I do not like StreamYard that much, kind of go back and forth, but this is what we're working with, is that we actually have graphs here. This is a really good illustration here. And it's actually varied over this past 7,000 to 9,000 years. The strength was actually weaker, not exponentially stronger, for much of the interval. Attempts to suggest that the Earth cannot be older than 10,000 years due to an exponential decay of the Earth's magnetic field are based on blind extrapolations of historical measurements, which span no more than 150 years into the past. This approach ignores the abundant of paleomagnetic data from human artifacts, sediments, and recent lava flows. And here we go. And I also want to point out that, of course, we do know that even most creationists accept that the Earth's magnetic field reversed in the past, mostly, I guess, due to the flood.
Which they don't have a way to explain how it reversed during the flood. Right. It just had to have.
Yeah, they're the same evidence that they would accept for one reversal. It's also the same line of evidence that tells us that it actually reversed over 170 times. And finally, there's a major assumption that is being made in this, because they always like accusing us of making assumptions. Under this, there's an assumption that the exponential decay rate has always been constant and always been decaying at a steady rate, phase. And so they say that we can't do that for radiometric dating, but here they are trying to use that for the magnetic field. I'm just going to wanted to...
Also, I'd like any creationist to give the mathematical equation that demonstrates that the magnetic field is decaying and the rate at which it's decaying. Also, why should the magnetic field be decaying?
Yeah, this is a good paper here. I'm going to cite this source because this looks like a pretty good paper. Reconstruction of Holocene geomagnetic field variation, new methods, models, and implications.
When is this from? July 2014. All right, it's pretty
okay.
recent.
So yeah, reconstruction of the Holocene geomagnetic field and how it varies on the millennial timescales are important for understanding processes at the core, but may also be used to study long-term solar terrestrial relationships. and as relative dating tools for geological and archaeological archives. Here we present new family of spherical harmonic geomagnetic field models spanning the last 9,000 years, based on magnetic field direction and intensity stored in the archaeological artifacts, igneous rocks, and sediment records. A new modeling strategy introduces alternative data treatments with a focus on extracting more information from the sedimentary decays. To reduce the influence of a few individuals' records, all sedimentary data are resampled in a 50-year bins, which also means that more weight is given to the archaeomagnetic data during the inversion. The sedimentary declination data are treated as relatively family values and adjusted intricately based on prior information. Finally, an alternative way of treating the sediment data chronologies has enabled us to both assess the likely range of age uncertainties, often up to and possibly extending 500 years, and adjust the timescale of each record based on comparisons with a prediction from a preliminary model. As a result of the data adjustment, power has been shifted from the quadrupole and the octupole to higher degrees compared with previous Holocene geomagnetic field poles. We find evidence for dormantly westward drift, more than high intensity flux patches in the core mantle boundary for the last 4,000 years. The new model also shows intermittent occurrence of the reverse flux at the edge or inside of the inner core tangents, cylinder, possibly originating from the equator.
There's also another point that I wanted to make, and that is that if Earth's magnetic field is weakening, its atmosphere should also be getting thinner exponentially with the weakening of the magnetic field, as that allows higher and higher and higher. As the magnetic field gets weaker, higher and higher and higher energy electromagnetic radiation coming from the sun should be able to hit Earth's atmosphere and sputter it away, essentially burn it away. We don't observe that at all.
Yeah. So here we have the different graphs being shown. Examples of model predictions.
I like how in the chat they're saying you're reading from Google when you're literally reading from one of the world's most respected geophysical journals. These people just are so out of bounds. It's not even funny.
Yeah.
Oh my God. I'm sorry.
Yeah.
Pi just said Dr. Lyle is one of the top in his field. I Googled him earlier today. No, he's fucking not. He has very, very little papers published. He is he is cited practically not at all. If you want to talk about the top people in the field in astrophysics, you're talking Sean Carroll. You're talking Lawrence Krauss, even though I don't like him. You're talking Stephen Hawking, who is no longer with us. You're talking Roger Penrose. You're talking Alexander Vilenkin. You're talking Katie Mack. You're talking people like Leonard Susskind. Lyle is not anywhere even remotely close to their level. And there's a reason why. It's because he's a hack.
Yeah.
I'm sorry, that comment just made me fucking laugh.
Yeah. Calibration of sedimentary declination. So we have the data. We have strong evidence that the magnetic field has not been decaying exponentially.
It hasn't been.
This is an unfounded assumption that assumes that the decay rate has always been constant, which it has not. And it completely ignores the strong evidence of the strong evidence of the geomagnetic reversals in the past. So again, wrong on all counts.
It would be like saying that the sun's magnetic field is decaying, but it's not.
Yeah. All right, let's continue.
Or carbon dating. A lot of times people think carbon dating gives the millions of years. It doesn't. No, all these.
I just wanted to point out here that he is actually correct in this case. Carbon-14 is only good up to about 50,000 years. And for the billions of years, we use other dating methods such as argon-argon, potassium-argon, uranium-lead, rubidium-strontium, and many other dating methods. Many people like to pretend that we only use one dating method, but we actually do not. So in this case, he is correct.
All these dating methods are based on certain assumptions, but the fact is a lot of them give ages. Even if you assume secular principles of uniformitarianism and naturalism, a lot of them still give ages, much less.
Wait, can we pause really quick? Why does naturalism have to be assumed for radioactive decay to work?
Yeah, exactly.
I mean, radioactive decay would still work the same as it did if God was proven tomorrow. I don't understand.
Yeah, and again, he wants to talk assumptions, but yet in his own argument, he makes the assumption that the magnetic field has to be decaying at a constant rate, but he gave no evidence for that. He
Yeah,
gave
and
no evidence for
the
that.
biggest thing is that if you press them on the math, say, give me the math that shows that I can examine, that I can work through, that I can cross-reference with people that work in these fields and know what they're talking about. Show me the math. None of them ever have, because they don't have it, because what they're claiming is happening is not happening, and so you can't have math for it. And if they did present math, the math would be wrong. The math wouldn't show anything that like they're assuming. So they don't give
Right.
you anything substantive, because they don't have it.
Exactly.
Years, including the fact that C14 has been found in things like diamonds that are buried deep down in layers.
Regarding the diamonds, we covered that last night. In short, what he is not telling you is that carbon-14 dating is good only up to about 50,000 years. And even by Dr. Snelling's own admissions, the carbon dates for these diamonds is well over 50,000 years old. So Dr. Snelling is lying to his creation audience by not telling them the whole truth, and so is Dr. Lyle. It would be interesting, however, if we carbon dated a diamond and it came out to be only 20,000 years old. That being said, as we discussed last night, nearby cluster decay does create carbon-14 and can affect the dating. And Jorge, if you want to talk a little bit more about the cluster decay, or Leo, if you had anything to add to that.
Yeah, I was trying to look up that carbon-14 and diamonds thing. I found it, and maybe I'm not looking in the right spot, but I found it for diamond batteries, which are man-made diamonds that utilize carbon-14. I wasn't able to find natural occurrences outside of creationist literature repeating that point. Do you know of like a non-creationist literature talking about that? Because I couldn't find it.
Yeah, exactly. Neither could I.
Well, that tells you everything you need to know.
Yeah.
Just like I searched up, and we'll get to it here when he starts talking about it, but his Dr. Lyle's particular model on distant starlight, I looked it up and couldn't find. The only things I could find were stuff from creationist sites and stuff from other sites like Rational Wiki and whatnot, refuting it and demonstrating how it doesn't align with anything that's currently relevant to the field.
Yep. Anyway, let's continue.
Of the Earth that are well insulated from cosmic rays. C14 doesn't last even a million years. It decays very quickly, and so the fact that you find it in fossils and in just about everything that has carbon in it is a strong indication that the Earth is not anywhere near billions of years old. Lots of stuff like that.
Wow, that's a great response. A lot of good information there, Dr. Lyle. With the comets one, for example, that limits the age of the universe. I've seen, as you pointed out, this Oort cloud that's constantly being invoked. But like you said, this Oort cloud is not actually based on real observable empirical evidence. Is that right, Dr. Lyle?
Yeah, I mean, it's the idea is with an Oort cloud that, and it's named after Jan Oort, the guy who came up with the idea. The idea is that there's a vast supply of potential comets out beyond the farthest planets, out way beyond Neptune, but we couldn't possibly detect them at that distance. There's no way to detect them. So it really.
And of course, that is simply a lie. We could, of course, detect the gravitational influence, and by tracking the many other ways of doing it.
Yeah, and as I already outlined, we know the periods of many comets, and we know that many of them are longer than Pluto's, but they're still gravitationally bound to the sun. So where the fuck did they come from?
Yeah.
All the simulations we run on our solar system's formation, literally almost all of them have a massive cloud of very small bodies, meteors, or rather asteroids, on the very, very fringes of our solar system. This is something we have observed in other solar systems that look very similar to ours. Despite the fact that we do not have direct observational evidence for it, doesn't mean that there's no good reason to assume that it's there. There's a lot of things that we don't have direct observational evidence for in science that we by all rights assume is there because it's reasonable, it fits well with our models, and it helps explain data. And it makes novel testable predictions that can be, and oftentimes have been, proven. Or I shouldn't say proven, but demonstrated.
Yeah, and I would also point out that we are observing a solar system forming right now in a young star, and I know we covered this before. The protoplanetary disk that has been formed. So we have a very good knowledge of how stars form and how planets form and how all of these form. So none of this is new. This is stuff that is taught in my first year entered into astronomy class. Anyway, let's continue.
Seems to be a rescuing device, a hypothesis that the secularists have invoked to protect their worldview from what appears to be evidence to the contrary. And they'll say, well, you can't disprove an Oort cloud. And that's true, I can't. It's undetectable. But there's no evidence for it either.
Yeah, you can disprove an Oort cloud.
Yeah,
that'd be pretty easy. Explain the data that we have from the periods of comets that are longer than Pluto, the simulations that we run about our solar system's formation that show that it's there, all that stuff with a model that can explain that. Provide a model that can explain all that stuff that doesn't invoke a cloud of small icy bodies on the fringes of the solar system. Yes, it is falsifiable. The problem is it hasn't been falsified.
Yeah, and I also want to point out that because of the great distance between the sun and the Oort cloud, it makes it very difficult to actually detect objects that far away. Mm-hmm. Simply put, we need to have light from one of the objects and all of that. Hold on, Maria Shaw. Oh, God, I like this comment from Maria Shaw real quick. Your series are a vaccine for the YouTube anti-science.
Well, we try to be. Some of them are YouTube anti-vaxxers, so
yeah,
you know.
Well, thank you for that, Marie. Welcome. We are glad that you are here. Yeah, and of course we do know that much more work is being done on that, and hopefully we actually can get a direct observation from it with the new James Webb Telescope and others. So again, we have it's not a rescue device because we have very good reason to actually believe that it's there.
They'll say, well, we find evidence of Oort clouds in other solar systems. Not really. We do find solar systems that have some kind of debris orbiting them, but we don't know that it's billions or trillions of comet nuclei. And even if you did find an Oort cloud, there's a problem in how would you make it under naturalistic assumptions? The idea is that
I can answer
some
that.
of those.
As planets form, their gravity working together begins to push the smaller debris as they're sitting there spinning rapidly in the protoplanetary disk, begins to push all of the smaller bodies further and further and further out. Gravity explains it. I didn't know gravity was supernatural here, Dr. Lyle. You're the fucking professional. You should know this.
Yep. And by the way, this is from the California Academy of Science. I like this video, so I am going to kind of play it real quick. This is actually a simulation solar system forming, because I think it is a beautiful video, and it's just
there is something I want to point out really, really quick before we start that. Well, how does this form naturalistically? Like if they say, well, yeah, okay, I acknowledge that could exist, but you can't give me an explanation how it got there. It's like, yep, I might not be able to. Be sure as hell no, it wasn't God magic.
Yeah, any natural explanation is, by definition, already a far better explanation than God did it. Yeah. So this is a really beautiful solar system formation simulation.
In the past few decades, our spacecraft have visited many exotic locations in the solar system, including icy comets that have orbited the sun since the planets were still taking shape. We have explored relatively tiny asteroids, ancient rubble piles held together by weak gravity. And we have found that the largest asteroids resemble the building blocks of planets themselves, all of which suggests that these objects offer clues to how the planets formed. And we have even found evidence for a violent rearrangement of the planets. Computer simulations allow us to reconstruct the formation of our solar system 4.6 billion years ago. We use the laws of physics to create these virtual experiments in order to figure out how planets took shape. After the sun ignited, most of the material around it had flattened into a disk of gas and dust. We can zoom into a simulation of a portion of the thin disk, a small piece of the universe in a box. Here, a dense swarm of objects clump together to form what astronomers call planetesimals. This simulation addresses how planetesimals form from much, much smaller particles, the size of pebbles. Pulled together by gravity, some planetesimals formed the planets, while others became asteroids and comets and dwarf planets. As the planets accreted, they carved out gaps in the disk. But the solar system remained quite cluttered. If we look at the orbits of the planets and accelerate the passage of time, so 1 million years pass by every 10 seconds, we can watch how the debris cleared. In this simulation, the giant planets, Jupiter, Saturn, Uranus, and Neptune, shift their orbits, and many unlucky asteroids and comets and dwarf planets get kicked out of the solar system. The migrating giants wreak gravitational havoc. The distribution starts out quite flat, but as most small objects get tossed out, others settle into stable orbits that allow them to coexist safely with the planets. But their orbits aren't as flat as the original solar system. Instead, they follow trajectories far above and below the plane of the planet's orbits. Today, the orbits of Pluto and other Kuiper Belt objects show exactly this pattern. The tiny icy worlds that inhabit the outer reaches of the solar system provide evidence for an ancient interplanetary transformation.
I thought that would be a good simulation to play.
No, that's cool stuff, definitely.
What do you think, Leo?
Yeah, that was really good. Pi's going off about something about why the planets don't have the same angular momentum of the sun or some shit like that, which makes no sense. I don't even know what point he's trying to get across. Yeah. It's kind of funny. We'll see if he can actually, make a cogent point or not.
That's a little bit longer, but yeah, I think the point's been made. This is one reason why I do not like StreamYard is kind of constantly having to shift back and forth between different things. But until I learn how to do this in OBS or an easier software, then this is what we're working with.
Have been flung out. Maybe Jupiter flung some of the original ice in the solar system out to the extremities, but the simulations I've seen of that don't get nearly enough of them out there to make an Oort cloud. So it's problematic if it's there, and it's problematic if it's not there. But since there's no evidence for it, I presume it's not there.
Right, great response. I've even seen a lack of confidence sometimes in the response from the uniformitarians and the evolutionists with the Oort cloud. So great response. So the next question then is a very common one, especially for you, I'm sure, Dr. Lyle. I want to first say great job in your latest informal debate with Dr. Hugh Ross.
Thank you.
I think I can speak for everybody when I say you really demonstrated just how scientific the young Earth creation model is. Now, the topic of distant starlight was brought up in that debate, and you gave some really great responses that I believe were not well countered or responded to. So my question would be this: given the biblical timescale that God created the universe roughly 6,000 years ago, how are we able to see stars and galaxies that are billions of light years away?
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. Well, that's absurd. I mean, you'd have to eliminate the resurrection and turning water into wine and all these things. But the way that I think that God got the light here is I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit of ahead of the other, but it took more time for light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances. And it turns out, this is something that Einstein wrote about, it turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror and bringing it back, and you're measuring the total time, total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people assume that it takes the light the same time to go that way as it does to go that way. We don't really know that. And
let's pause right here.
To know.
So the first thing is there really isn't such a thing as a one-way speed of light for the reason he explained, that whatever and it's synchronicity. It's not synchrony is not a word. It's synchronicity. There we go. I kept wanting to say synchronicity. Synchronicity convention is what it is. And you can change your synchronicity convention to essentially make the speed of light in one direction, moving from point A to point B, whatever the fuck you want it to be. So there is no way to demonstrate that the speed of light is moving at any speed from point A to point B. But they're the ones making the presupposition that the speed is different going from point A to point B than it is from going point B to point A, back to point A. So he's saying, well, they're making a presupposition that it doesn't change. No, you're making that assertion on your presupposition that it does change, which isn't supported by the math. And his model is called the anisotropic synchrony convention. And the thing is, well, that's what his model is called, but that's not actually his model. That's something that's existed in the science for a while. And the thing is, mathematically speaking, it works because it can be used to explain our universe as we see it today. And what it says is that light travels from point A to point B infinitely, which already brings up problems because having a quantitative infinite in reality just brings up a pile of problems in math, but then travels at half the speed of light when it comes back to us. So when you average that out, you get just the speed of light. Fine. I mean, if you really want to use that, you can. It's just you're needlessly and overwhelmingly overcomplicating the math, which means that you're now violating Occam's razor.
Yeah, and by the way,
the other problem. Go ahead.
Yeah, I want to point out that I actually did the math on this. According to the young Earth timescale, they have from the nearest star, the light has only 2 days, 48 hours to get from where it is to Earth so that Adam can see it. I did some calculations using the nearest star, Alpha Centauri, which is about 4.36 light years away. If you wanted to get from there to here in only 48 hours, the one-way speed of light has to be over 710 times faster than the quote-unquote round-trip average. This brings up a whole lot of problems, and as others have pointed out, The speed of light is tied to other fundamental forces of nature. So people like to pretend that the speed of light can speed up and slow down on a whim, but it can't. The speed of light is dependent on other physical constants. And if you want to change the speed of light, you got to change those constants. So what is the mechanism by which the speed of light is hundreds and hundreds and hundreds of times faster one way than it is going back? And if the speed of light is instantaneous going one way, then it should stand to reason that it should be instantaneously going the other way as well.
Yeah.
So
and that's the problem with his model. He's assuming that the speed of light is moving from point A to is moving one way infinitely and then back from us at half the speed of light. You can change those numbers to whatever you want as long as the average between them is c, is the speed of light. It's completely arbitrary. So why should we take his model when it significantly overcomplicates, needlessly overcomplicates the math? It makes no sense. But the thing is, his model isn't just an anisotropic synchrony convention. His model involves biblical creation. It involves a literal 6-day creation week. It involves God magic and all these other things that have absolutely no basis in reality. The Poincaré Einstein convention is the one that scientists use. And there's a reason for that, because it is the most accurate one. Not to mention there's all sorts of assumptions that would have to fall out, that you would have to make for his particular model to be true. Namely, that the further back we look in the universe, further out we look, the further back in time we're seeing. So everything, the Earth, and what's close to the Earth might have been created 6,000 years ago, but stuff further out would have had to have been created sooner.
Right.
And this is on his model. If his ASC model is correct, then that has to be true. There's no reason to think that. He literally just does not have a model. There's a reason why literally nobody in these fields accepts his model. How do you explain that away? How do you explain away the fact that literally no aspect of physics accepts ASC?
Yeah. And
something I was wondering, maybe he's going to attest to this at some point, but if there is a two-way speed of light, one way is faster than the other necessarily, wouldn't that be able to be experimentally proven with like a blue shift?
That's something else I forgot to mention. That's unfalsifiable. You can't prove it because you can't ever measure the speed light going one way. So he's proposing a model that's fucking unfalsifiable.
Yeah,
I mean, you could say take a distant object like the moon, and you could shoot a laser at the moon as the moon's coming towards us. Shoot a laser at the moon as the moon's going away from us. If you get different results that beyond simply the fact the moon is moving towards us, moon is moving away from us, account for that, and you get something different, then maybe that proves something. I don't know.
We already tried. We already did an experiment to try to show that.
Well, exactly,
and that was the Michelson-Morley experiments looking for the aether. If his model were true, it's not doesn't mean that there has to be an aether, but it makes it more likely that there is. We didn't find an aether because we did not find that the speed of light varies due to the drag of the Earth moving through that aether. Again, helping to bolster the idea that the speed of light is a constant. Like I said, there's a reason that the only fucking physicists you will find that think the speed of light isn't constant are creationists, and they've already surrendered their credentials once they've admitted they're a creationist.
By the way, I want to point out one final point, is that E equals mc squared. E, of course, is energy, m is mass, and c is the speed of light times itself. If you change the speed of light to hundreds and hundreds of times faster than it is, you're inherently going to get more energy. Yes. And that is deeply problematic.
Mm-hmm. Yeah, the amount of energy that anything has would just vary as the speed of light does in any particular situation. Our GPS system works on the speed of light being constant. The whole standard model of elementary particles uses c squared or c to the fourth. I mean, literally all of modern physics would be wrong, and it's not. We know it's not because it all blends together so well and has made numerous novel testable predictions, almost all of which have come true. We have verified these things experimentally. We've verified these things mathematically. We've verified these things observationally. Like I said, his model is nothing but one big, massive, special pleading violation of Occam's razor.
Right. And let's continue.
That people say, why would it be different directions? Well, I don't know, but there's no reason why it would have to be the same either. And I found this the concept's a little bit difficult for laymen to grasp because it takes a little bit of knowledge of the physics of Einstein. And so I actually wrote a book about this topic called The Physics of Einstein, where it brings people up to speed on the physics that they would have to know in order to recognize why you can't actually objectively measure the one-way speed of light, because you'd need two clocks that are exactly synchronized, and there is no objective way to do that in the universe. There are subjective ways to do it, where you can say, I'm going to call this synchronized. And some.
By the way, even if we were to accept this argument here, the actual margin of error that we would actually get in our measurements would be so astronomically low that we would have like less than a 1% margin of error in our calculations of how fast the speed of light is actually going.
It's also worth mentioning that speed of light is not just the speed of light. They would have to argue that gravitational waves, that we can't measure those one way, that those would have to reach us instantaneously. But they don't. They travel at the same speed that light does. That's how when we get mathematical data from gravitational waves, we know, okay, yeah, this definitely came from something that's, say, 8 billion light years from Earth. It didn't get to us instantaneously. The speed of light isn't just the speed of light. It's the speed of communication in space-time. It is the maximum speed that anything is capable, whether it has mass or no mass at all, is the maximum speed that anything can move in space-time. It is essentially a quote-unquote rule that space-time has. Hey, I'm not going to let you go this faster than this in me, because there are all sorts of paradoxes. He hasn't addressed any of the paradoxes that arise from the speed of light moving faster, namely that you can see backward in time, that time would have to be going backwards, why we haven't observed tachyons, none of this. None of, like, this model just makes no fucking sense whatsoever.
By the way, for the lay people in here, what are tachyons?
Tachyons are hypothetical particles that were proposed and were never really highly accepted, and the evidence is not in their favor, that travel faster than the speed of light. So they have a negative mass, and the problem with adjusting the speed of light to making something go faster than the speed of light is especially in the Lorentz transformation for time dilation. I think it's T prime is equal to 1 over the square root of V squared divided by C squared. If you increase V in that equation above C, you don't get a negative number, you get a complex number. And this makes all the math just go wacky. It's like the infinities that we get when we try to apply general relativity to extremely small yet extremely energetic scales, like the singularities in the black holes. We get singularities, which is where the limits tend to infinity. This is a signaling of the breakdown of the math. It doesn't mean that the density of a black hole is literally infinite. It means that the math is not accurate enough to describe the environment that we're applying it to. You would essentially be the same thing if you put that V, if you put the value of V in that equation above C. The math just isn't going to work. I would like to know how he addresses this. I would challenge Dr. Lyle to a debate on this, but he only dates academics, which is a way. And the funny thing is, it seems that he only dates academics that are also creationists, at least to some degree, whether young or old.
Yeah,
I guarantee you he would not debate Sean Carroll. I guarantee you he would not debate Leonard Susskind. I guarantee you he wouldn't debate Lawrence Krauss. He wouldn't debate. He would debate none of them, because he knows they could easily prove him wrong. Easily.
Yeah, exactly. And I will point out that I love Dr. Sean Carroll. He completely and utterly humiliated William Lane Craig in his debate.
God. And I love when, and I know we're kind of going off on a tangent, I just want to say this.
Yeah.
Really. Number one, Dr. Sean Carroll is like my number one influencer. It goes Sean Carroll, Alex Filipenko, and Richard Feynman. But in that debate, Dr. Craig tried to tell Dr. Carroll that essentially that his own model was wrong for these reasons. And then Sean Carroll comes back up and explains that, no, the model isn't wrong for these reasons. I admit it's only a hypothetical model. I'm not saying that we verified it or proven it, but the problems he's associating with my model just really aren't there because of unitarity. And then Dr. Craig again states that, no, your model is wrong because of this. And Sean Carroll comes up and says, no, my model isn't wrong because of this. I would know. I wrote the model.
Yeah, exactly.
Jesus Christ, God.
Yeah, and we're already almost an hour into this live stream, and we're only 15 minutes into the Standing for Truth interview. So this is going to be a long night. But anyway, let's continue.
Actually, I got to, real quick before I continue, something else I got to hit the hay. So this something I doubt he addresses, but would be a big obvious question beyond the mechanism of light speeding up is the mechanism of light slowing down.
Yeah,
like,
exactly.
If light is changing its speed, how? What slows down light? Does light have the ability to do this itself? I mean,
Yeah,
there's
right.
you know the
Now we do know-
mechanistic issues are
Right. Now we do know light does speed down in different mediums, such as
yeah,
liquid.
but that's not necessarily the speed
but-
of
but
light
that-
changing.
but
It's the light's path being longer.
Yes,
Exactly.
that's exactly what it is. This is a big thing. I really appreciate you making that statement, Olga, because that is important. When photons hit a medium, their speed doesn't change. What you could say is so a vector has two arguments: direction and speed. Only one of those arguments changes when the vector defining a photon hits another medium, and that is the direction vector. The speed vector stays the same. So a photon hits a medium and is immediately absorbed by an electron. When it's emitted by that electron before being absorbed by another one, it is still traveling in vacuum at C. It's the same way as if you throw a ball at 100 miles an hour at a wall versus throwing a ball and it stays at 100 miles an hour through all the bounces. We're going to ignore the conservation of energy for this contrived hypothetical, but you're bouncing it off of trampolines. They're both moving at 100 miles an hour, but which one's going to hit the wall first? The one that's going on a straight trajectory to the wall. The one that's going on a curved trajectory is naturally has to travel through more space, and so will take longer to get there. The speed of light doesn't change. The trajectory of the photon changes.
Correct. So if you want to change the speed of light, you have to change the trajectory, pretty much.
Yeah. So yeah, I gotta go to bed. Have fun
All right.
with this shenanigan. But Leo, I don't know if you ever heard. You might want to be interested in looking up Cherenkov radiation.
Yep, I know what that is. Yep.
Oh, you do? Okay, good. Because that is,
it's interesting stuff.
Yeah, it's ridiculous stuff. So, anyways, I'm going to bed. Good night, guys.
Take it easy.
All right, good night, Morgan. All right, let's continue.
Somebody else is free to disagree and say, no, I don't think they're synchronized. I think they'd be synchronized if this one was turned a little bit ahead of that one so that now they're synchronized. And the bottom line is, if you use the ancient method of synchronizing clocks, which is a visual synchrony convention, clocks are synchronized if they look like they're synchronized, basically, then light takes no time at all, even today, to get from those distant galaxies to the Earth. And so it can actually arrive instantaneously.
Any thoughts on that, Leo?
That's a violation of special relativity. Nothing can be instantaneous in reality. Nothing.
Yeah, exactly. Because remember, it has to go from the light. The photon has to come from the star or whatever it's from, and all the way to Earth. Simply instantaneous cannot happen.
I would love to see Lisle go up against someone like Sean Carroll, who's got a little bit more of knowledge, like in quantum field theory, than Dr. Lyle would, because Dr. Lyle's an astrophysicist. I mean, he's taken quantum mechanics and advanced quantum mechanics, but he hasn't taken like the quantum field theory and the advanced quantum field theory, standard model and stuff, classes on stuff like that, because most of what he's saying would violate quantum electrodynamics.
Right.
And that is probably one of the most singly well-confirmed theoretical frameworks that humans have.
Yeah, and I really don't understand his point that if they look synchronous, then light travels instantaneously. I really do not understand that.
It's a non sequitur.
Yeah.
What he's doing is he's essentially special pleading. Like, well, my synchrony convention should be the one that we use because it proves my point.
Right.
That's just fucking special pleading.
Right. Anyway, let's go. Let's continue.
And that doesn't violate any physics. It's actually perfectly consistent with the physics that Einstein discovered.
It violates special relativity, which says nothing can be instantaneous. Oh my God. And this is what I'm saying. This guy, Lisle, knows this. I know he knows this. He's using lying because he's pandering to an audience that he knows doesn't have the technological knowledge to know that the shit that he's saying is bunk.
Yeah. And by the way, just even Wikipedia, just look at special relativity. The theory is based on two postulates. That number one, the laws of physics are invariant, that is identical, and inertial frames of reference, and that is frames of reference with no acceleration. And point number 2 is that the speed of light in a vacuum is the same for all observers, regardless of the motion of the light source.
And that is
or
because
observer.
essentially the speed of light. So if I'm I'll have to do it with my fingers. You have got a coordinate space. Imagine coming out from 0 at 45-degree angles. That would be light. Under a Lorentz transformation, you move this like this, and you move this like this. So essentially, you go from like this to like this. That beam of light will still be at 45-degree angle. It doesn't change. It's invariant under Lorentz transformations. So, and that's one of the ways that we know that the speed of light is constant. Other vectors will change with those transformations. Light doesn't. The speed of light doesn't. It is invariant under those transformations.
All right, let's go.
It's just that a lot of people don't know about it. And I know that's a little bit abstract. I found that it takes probably at least 20 minutes really to bring people up to speed on the basic issues so that they can comprehend the thrust of the argument. But I do have a series of articles on our website at biblicalscienceinstitute.com. Our latest articles are on this very issue. I've been bringing people up to speed on the Starlight issue, some of the other solutions that have been proposed, and why I think this, what I call the anisotropic synchrony convention, is the best method. It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore,
his argument's own defeat. He literally just admitted it. So like I said, let's go ahead.
Yeah, I want to point out, he said point blank that no one can disprove the model.
Yeah.
In other words,
we both taught that, yeah.
yeah. He even just admitted that no one can disprove this. In other words, it is an unfalsifiable model. And if your model is not falsifiable, then it isn't science.
Scientific, yes. And another thing is, I already pointed out that anisotropic synchrony convention, you can get the same results that we see. You could use that in physics and describe our universe the same way it is, but the math would be significantly more complicated, significantly more convoluted, and it's thus a violation of Occam's razor. His model is not just ASC, anisotropic synchrony convention. That is a concept that is an extension of special relativity. His model takes that, but then also includes, like I said earlier, a 6-day creation, God magic, all that stuff. His model includes those extra obviously fucking bullshit bunk ideas, along with ASC, which is already not taken seriously by the overwhelmingly vast majority of physicists because it overcomplicates the math. So he's not wrong when he says that it doesn't violate the laws of physics. He's technically not wrong there, but it just overcomplicates. It was like when I said pilot wave theory. I don't know if I gave that example here. I gave it to somebody else, I think. You can use pilot wave theory for non-relativistic quantum mechanics and have no problems whatsoever. But nobody uses it. Why? Because it overcomplicates the math. At the same time, once you start getting into relativistic quantum mechanics and quantum field theory, there's all sorts of problems. It can't describe those, but yeah, and that's the same thing with ASC. It starts to fall apart once you delve deeper into the sciences.
Right. Anyway, let's continue.
For there is no distant starlight if you understand physics.
Awesome. That was a great answer. Matter of fact, even going back to your debate 2 months ago with you, Ross, he objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? Right. So it appeared that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that?
Hold on. Let him answer that actually, and then I'll respond.
Specifically.
Yeah. When he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. It depends on what units you choose to make the measurement with. And so whenever anybody asks that question, does it take light 8 minutes to get from the sun to the earth, or does it get here instantaneously, or 16 minutes? And the answer is it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate.
That was pretty much a non-response because light literally takes 8 minutes to get here. We know that by having data come in from observatories we have closer to the sun. and being able to match that with how we can pick this up on Earth. So we know that electromagnetic radiation takes a specific amount of time to get from here to the sun, because not only can we see that with the sun, but we can see that with the, like, our solar observatories. Any information they send us takes 8 minutes to get here.
Yeah.
So he's pretty much just providing a non-response here, because he doesn't have a viable response to that question.
Yeah, exactly. And let me just look up the Sunspot Solar Observatory real quick. It takes approximately 8 minutes, 20 seconds for light from the sun to travel to the Earth. The speed of light on the scale is 3.24 miles per hour, or 4.75 feet per second. Just seeing real quick. Yeah. What was your source for that? Just curious, just so I can get a citation for
Source
the
for what?
For what you just said about the observatory, just so I can put it into comments.
I wasn't reading it from one. I just know that.
Okay.
A lot of people ask me, what's your source for that? And I'm just like all the physicists that have told me that, the books that they've read and things, like the books that I've read that they've written. Yeah, the Soho, I don't even know if we use Soho anymore. I think we use one. But anyway, I mean, same basic principle. Like, we also know this because messages that we send to other spacecraft that we have out there take a particular amount of time. Like, when we send a command to something like, say, on Mars or something that's looking at Jupiter, that command isn't carried out by the craft until the message gets there. Why does it take time?
Yeah. And by the way, I wanted to also make this note. When you actually, if you were to actually take a look at the videos from these moonwalking, it actually takes, you'd think that there's a little bit of a pause between when the question was asked and when it was answered. And that pause is because of the time it takes to get the message from here to there.
About 2.5 to 4 second pause.
Yeah, exactly. Which is exactly what we would expect from our math.
Yep.
So yeah.
Everything, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing we think it is. It's affected by motion, gravity, and things like that. And so the amount of time it takes light, the amount of time it takes light to get from A to B and back to A, that's objective, and that time is objective. And there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it. But the one-way speed depends on how you choose.
Notice again how he just
and did he really just say that it was set by God?
He's just appealing to God magic. It's set by it's just an aspect of reality because of the paradoxes that would arise if you could exceed the speed of light. Like, you notice how a lot of creationists appeal to the law of causality. Well, if the speed of light could go faster than what it is, that would violate the law of causality, which isn't really a law because it breaks down at the quantum level of reality anyway.
Yeah. And again, as I said before, there's no mechanism for which it could be one way or another. So what's the mechanism by which it speeds up or slows down?
Mm-hmm.
To synchronize clocks. And so does light take 8 minutes to get from the sun to the Earth, or does it take no time at all? The answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention.
It's like asking, does it take at 60 miles an hour? Does it take you 6 minutes to go 10 miles, or does it take you 40 minutes? Well, it's both. He's literally making a fucking contradiction here.
Yeah,
it can't be both. It's either instantaneous or it takes time. Which one is it?
Yeah, this is a logical contradiction. One of these things is not like the other. One of these things is wrong. Yeah, the old Sesame Street game.
Convention you use. And I believe the Bible's using the more ancient synchrony convention in which celestial events are marked by when you see them. And so in using that system, God created the entire universe. The light was immediately visible to Earth on day 4 as soon as God created the luminaries. And that gets around a lot of these other issues too of, people saying, well, God made the light already on its way. Well, then he's making pictures of things that don't exist.
So yeah, basically what he's saying is that we have so much information from the supernovae and other things that if it was created in transit, that these would basically be imaginary stuff or whatever.
Man, creationists really. If it wasn't for them, I wouldn't be able to have a YouTube channel. I don't think any of us would. So thank you. Thank you,
This
Dr.
gets
Lyle.
around all that because all the stars that we have pictures of really existed in real time. It's just that we see them immediately.
So basically, I guess his model is basically saying that these supernovae that we observed and all of that, these are happening at the same exact time that we observed them, which of course is nonsense.
Yeah,
So,
that's a problem. If light travels instantaneously to get here, then all things that we see happen at the same time, but they don't.
yeah.
So how? I mean, just God, I don't even think he's got a model. He's just got a baseless assertion in some vaguely correct special relativity math to try to make it seem scientific when it's just not.
Yep. So let's continue.
Oh, I love it. Great answer. We've got a lively chat who are really enjoying this and who really enjoyed your debate with Hugh Ross a couple months ago and share my opinions with it. Here we've got Tony Torpa. Question came in. Hi, Jason. Has anything been heard from Hugh Ross when you challenged him to read your article, Distant Starlight and ASC, in your last debate? Thanks for your new posts on the subject. They are awesome.
Thank you for that. No, I haven't heard from Hugh Ross. I hope that he did look at that article because he was under the mistaken impression that light from a supernova could be used to measure the one-way speed of light. It cannot. And I had already answered that because there was a
Anything you want to say on that real quick?
Nope.
critic named Peter who had posted that same thing. And I demonstrated that, in fact, Peter had made the assumption in his question that the speed of light's the same in all directions. Otherwise, his question wouldn't make any sense. The fact is you get exactly the same answer for when you see the light from a supernova that's been gravitationally bent. You get exactly the same answer whether the light in one direction is instantaneous or whether it's C or whether it's any other value that's allowed. And the reason for that is light can only be instantaneous in one direction relative to a given observer. And so the light from the
What did you say? Did you say anything, Leo?
Nope. Just been listening.
Okay.
supernova would have to go at an angle, and so it wouldn't be quite instantaneous when it first goes out until it gets bent around the galaxy and then zips directly toward the observer. And so I answered that, and Hugh hasn't got back with me yet. I hope he will. If he wants to, if he thinks I'm wrong, he's welcome to challenge me, and I'd be happy to post his reply and my reply to his reply and so on.
Awesome. Yeah, great response. I mean, it looks like oftentimes I find that the critics, even some of the most militant critics, just aren't really up to date on the literature on this anyways.
Yeah.
So I guess you
I do have something to say about that.
What was that?
And that is that up to date on the literature, his model was proposed in 2010, 10 years ago.
Yeah.
He's not proposed anything new on it. There's not anything, and it's not even published in any relevant journals. It's published in fucking creation journals, which aren't really journals.
Yeah, they're not journals, they're blogs. It's kind of an insult to actually call them journals because they're not.
I try to not call them that.
Yeah.
Answered this, but a question would be, how do you feel the critics have responded to your arguments overall, Dr. Lyle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you. People who are physicists and are trained in relativity have.
You can't see what you
some
don't
of them have
look
said,
for.
well, Lyle's.
I said you can't see what you don't look for.
Yeah, and by the way, I also want to point out that most of it, that 99% of the physicists out there don't take creationist literature seriously. So of
Exactly.
course, it's not going to be. They're just
They're
like, it's not going to be worth responding to.
Yeah, they're not going to provide a rebuttal to it because it's not something that's been feasibly demonstrated to begin with.
Right. It's like, why do all the immunologists not respond to the people who are anti-vax or who deny the germ theory of disease? So of course, they're not going to take them seriously. They're not going to even bother responding to them.
Yep.
Right about that. So, and of course, some of the papers that promote an ask type model, like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention. So I haven't seen any real. I've seen internet rebuttals by people who don't seem to be trained in relativity. I've seen one that says, well, no, you can't use that coordinate system where it would create a gravitational field, which we don't see. No, that's not the case. Switching coordinate systems does not create a gravitational field. You can measure things in polar coordinates. You can measure them in rectangular. You can measure using an Einstein synchrony convention or the anisotropic synchrony convention. It doesn't create any magnet or any gravitational fields. And anyway, it actually the most of the ones, if you go back a few months back on my website where I respond to Peter's objections on distant starlight, most of the ones that I've seen on the internet, he repeated those and I answered them. So I haven't seen any ones that are a serious challenge from a physics perspective because, frankly, the conventionality thesis upon which my model is based is really pretty well established. I consider it proved. John Winnie back in...
The conventionality thesis is what I mentioned before, and I'm going to mention it for the third time, that technically, yes, we can use ASC, anisotropic synchrony convention, and be able to make our universe look the same as it is. The physics would be fine. But his model is based on that. It incorporates ASC, but it's not just ASC. If he was just somebody that's like, you know what, I come from an ASC perspective, and that was it, that would be fine. I mean, there'd be nothing wrong with that, other than all the excuse me, all the mathematical complications that are embedded in it. And it's just a matter of Occam's razor. We have two models. We have Poincaré-Einstein synchronicity. We have anisotropic synchronicity. This one, what was ESC, also known as Einstein synchrony convention. We have ESC and ASC. ESC and ASC explain the same things, but ASC has much more complex math, some other added assumptions to it that make it a little bit more complicated and convoluted than ESC. Well, Occam's razor dictates that the more complicated one you shave away, so to speak, and you utilize the simplest one because they both still explain the same things in the same ways with the same results, but the more complicated one is just unnecessary. You don't need it. So he's not wrong when he says that this synchronization convention. Yeah, that's a thing. I've mentioned it now thrice, but there are reasons why ASC. Excuse me again. There's a reason why ASC is just not utilized by like 99. I would argue pretty much all physicists. Like Lisle is one of maybe a handful that are going to be using the ASC. And there's a reason that they're using that, and that's because they're predisposed to a creationist assertion because they're not models in the first place. So there's that.
Yeah. Let's see here.
1970 showed that all of special relativity can be done without the one-way speed of light, leaving it as a free parameter, which the epsilon, the Reichenbach epsilon. So I haven't seen any rebuttals at all, really, other than ones that are kind of on the internet, not peer-reviewed ones.
Right, you're going to get that with everybody, though. I mean, you
Sure.
see that everywhere. The internet,
Of course.
The internet's the criticism area. So here's one. You did answer at least the first part earlier, but I'm just going to read the entire thing for you because this was a critic question. So the objectum, for the sake of argument, let's accept that your claim for the round trip average speed of light is 186,000 miles per second. If this is true and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is no simply no reason to think that the one-way speed of light is over 700 times faster than the round trip speed of light.
By the way, I do want to point out that this was my question that I emailed Standing for Truth. So I do want to make a huge thank you to Standing for Truth and Rollmat for actually asking my question. I really do appreciate you guys taking time to ask it.
Well, when people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying, the metric system is clearly the correct way to measure things, and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter, and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razors. Well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system.
The point that he's making here is essentially.
And here's the point.
You go first.
Okay, yeah, and the point, and this is exactly the reason why most of the world prefers the metric system, because it is so much easier than the system.
God damn it, you said what I was going to say. Well, I'm going to play into that, but that's essentially the conclusion I'm going to get to. He is correct in essentially stating that nature doesn't care how you measure the speed of light. However, that being said, that doesn't make the speed of light any different from what it is, how we measure it. That, well, we can say that in one direction it's instantaneous, but not in the other. That's not a part of physics. Just like nature doesn't care how we measure anything else, whether we use the imperial system, not the English, the imperial system, or the metric system. But there is one that is obviously more simple than the other. And it's the same way with measuring the speed of light. Measuring something in feet or inches or meters doesn't change the length of the thing you're measuring. Just like saying that the speed of light could be infinite in one direction, but not in the other, doesn't actually change the fact that it's not ever infinite. So he's right. Nature doesn't care how you measure things, but that doesn't change the objective quantity of whatever it is you're measuring. And there are ways of measuring it that are more simple and more palatable than others, like ESC, Einstein Synchrony Convention, versus ASC, Anisotropic Synchrony Convention, just like the metric system versus the imperial system.
Right, exactly. Let's continue.
It is. That's why scientists, we like metric. And we do all our calculations in metric, and then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be, and that will tell you how to synchronize two clocks that are separated by distance. And I know that's counterintuitive, but folks, if you're gonna if you're gonna argue on this principle, you need to get up to speed on the physics of this. This has been discussed. This topic of the one-way speed of light and its immeasurability has been discussed for over a century. There's a century worth of literature out there devoted to this topic. And not long ago, I came across a book somebody had written. Max Jammer wrote a wonderful book called Concepts of Simultaneity from Antiquity to Einstein and Beyond. And it's a nice summary of the scientific literature, written really pretty much at a layman level. And so that's a nice way to get up to speed on these issues. But when people say, well, it's more like the speed light's more likely to be this and than that, or there's no evidence that it's one way or the other. No. This is a convention of measurement. It's a convention by which we decide what we're going to call synchronized when we have two clocks separated by distance. That's all it is. And that's why there is leeway in terms of how you.
I just want to reiterate, because that's kind of what he's playing at again, that yes, just like metric versus imperial versus measuring things in blurks or blues or whatever you want to use, like there's 13 blues in a blurk, there's 9 blurks in a schlim. I mean, you can make up any convention for measuring something. How you measure it doesn't change the objective values of what you're measuring. He's exactly correct. You can measure the speed of light as being infinite in one direction, but not in the other. But that doesn't change the fact that the speed of light is actually still a constant. Just because we can adjust our measurements to make something work, despite it seemingly being, counterintuitive, doesn't mean anything. It is a matter of conventions, but those conventions don't change reality. And that's the point that he's missing. And that's the point that all of his dumbass creationist followers are also missing. And I'm sorry, it might be a provocative, but they are. They're idiots.
You choose to set the one-way speed of light. It's not something that can ever be measured. It's because it's not an objective property of the universe. It's a human choice.
Right. That's a great response. These critics, like you said, Dr. Lyle, they need to get up to date on this. This physics, as you said, is known and it's understood. And it's probably why you have not had any convincing rebuttals. So that's a great response. This is awesome. A couple super chats I should get to. The chat's lively and I may miss these.
Can we pause this right here?
$10.
Because I'm gonna read this question because this is a really dumb question. Dr. Lyle, would SN 1054, the supernova observed in 1054 AD, prove your theory of distant starlight? It was witnessed in real time, meaning it didn't take millions of years for the light to reach us. No, it wasn't witnessed in real time. It took that light time to reach us. That I don't remember the exact dates. I'm gonna have to look it up. But I think we were capable of calculating when it actually went off. It was first observed on July 5th, 1054, and remained visible for about 2 years. Let's see what it says about. I'm trying to figure out how far it is. Let's see if it tells us its distance. This it's 6.5. It's 2 kiloparsecs. So it's 6.5 kilo light years. A kiloparsec is, what is that? A billion? Is that a billion parsecs? I can't remember. Kiloparsec. No, that's 1,000 parsecs. So it's 2,000 parsecs. It's 3.26 light years in a parsec. Let me do some math here.
It looks like about 6,500 light years.
0.26 times 2,000 equals, about 65. Yeah, you're right. About 6,500 light years. So it went off 6,500 years earlier.
Yeah, exactly.
Now, the thing is, you can say that it went off right when you saw it. There's nothing wrong with that. Again, like he said, that is a matter of convention. But does that convention map to reality as well as we can get it to? And ASC just doesn't.
Right.
Super chat from Conservative Christian. Thanks so much. We appreciate it.
Yeah, I was going to say you might want to
Dr. Lyle.
There you go.
Would SN 1054, the supernova observed in 1054 AD, prove your theory of distant starlight? It was witnessed in real time, meaning it didn't take millions of years for the light to reach us.
Okay, I would say it doesn't disprove my model, but it doesn't prove it either, because if you use the anisotropic synchrony convention, that explosion actually happened in 1054 AD. That's, by the way, the explosion that produced what today is the Crab Nebula, and the Crab Nebula is still expanding, and so we can actually work it back and figure out when it exploded. And you get roughly the right answer. We know from history, we know from recorded history, it was 1054 AD. And so one of the exercises I have my students do is to try and estimate what that date was, and they get an answer usually pretty close to the right date. But yeah, so that it's just a question of whether that actually happened.
Because I have a serious question. What students? He doesn't teach at a university, as far as I'm concerned. He's not a professor anywhere, as far as I'm concerned. What students? You mean the people that you're training to become creationist apologists? Those students?
Yeah, exactly. And he's a professor. So yeah, it doesn't look like he's ever been a professor. So I would like to know which students he's talking to.
Exactly.
Or maybe he's just saying anyone who he's talking to. I really don't know.
I feel like he's just using that term to make it seem like he's like an actual professor or something when he's just not. It's either disingenuity or it's dishonesty. I don't know which one.
All right, let's continue.
happened in 1054 AD or whether it happened previous to that. And that, by the way, that supernova remnant, it's not millions of light years away. That's well inside our galaxy. I don't remember its distance, but it's a few thousand light years away. So even if you assume the Einstein synchrony convention, that would just mean it actually happened sometime probably before Christ's earthly ministry, the actual explosion, and then we finally saw the light from it in 1054. Whereas if you use the anisotropic synchrony convention, then it actually happened in 1054 AD, and we saw the light immediately. So there's no way observationally to distinguish between the Einstein convention and the visual or anisotropic synchrony convention.
Awesome. Yeah, this stuff's so fascinating, Dr. Lyle, and you make it so understandable for us. I want to thank you for that. Question here from Vitalis at SFT for Dr. Lyle. Do you think light is subject to anthropic forces due to a closed system universe?
Can we pause here? So, and she, well, he, first I thought that was a female, my bad, it was supposed to be entropic, not anthropic. And technically, yes, in the sense that after enough, like the cosmic microwave background was very, very high energy, like probably gamma ray or X-ray radiation when it was first released, and it's now microwave. That's due to entropy. So yes, light is subject to entropic forces, but that doesn't change the constancy of its speed. And by the way, the universe is an isolated system, not a closed system.
And just for the layman here, what is the difference between a closed system and an isolated system?
Closed system, I believe, allows energy to move between it, but not matter. An isolated system is neither energy nor matter can move within or without it.
Okay.
Into it or out of it.
Anthropic. I don't know what he's referring to. I'm sorry, I don't think I understand the question.
No, that's fine.
Of course, we don't know if the universe is closed anyway, so I don't know how I could answer that, even if I understood.
Yes, it's isolated.
Really.
No problem. No problem. Vitalis, if you can clarify at some point, then maybe we can get back to that. So the next question, Dr. Lyle, would be, we often hear that cosmic background radiation is evidence of an old universe. What would be the best response to a claim such as that?
I think the best response would be why. How does that in any way prove that the universe is old?
I can answer that. It proves the universe is old because we can measure how far out it is, and we can also figure out what it was released from. It was released about 13.8 billion years ago. It extends about 13.8 billion light years in every direction. There's two places where it matches up. And it was released during the period of recombination when photons decoupled from matter as it began to cool as the universe continued to expand.
Yeah, and I just wanted to point out that the cosmic microwave background was actually predicted by the Big Bang Theory several decades before it was actually discovered.
Yes.
So you can't.
What was that?
What was that?
I was going to say George Lemaitre, I think, proposed his Big Bang model in 1927. We observed, well, Edwin Hubble observed galactic redshift in 1929. We didn't observe the cosmic microwave background until the 70s.
60s. I think it was.
Let me look this up.
I thought it was the 60s.
Yeah, I think you might be right. I think it was the 60s. I'm going to look it up, though, just because I want to know what the exact date was. Yep, you were correct. 1965.
Yeah, and the gravitational waves predicted by Einstein were not found until 2016.
2015.
So,
100 years after he proposed general relativity, the theory.
Yeah, sure. So you don't get more scientifically empirical than saying, I have a model that predicts we should see X, and then we see it decades later. Yeah, exactly. And even better when we see it decades down the road, and we can look back and say, aha, this is the model that predicted this.
Yep.
So the cosmic microwave background is best explained by the theory that predicted it.
And one thing that I want to mention here is one of the big reasons that we know that it's essentially the light left over from the Big Bang, a sort of a layman's way of putting it, is because it is nearly homogeneous, uniform throughout the 13.8 billion light years that it extends.
Yeah. And Creo
made
a good comment here that the temperature of the background radiation was also predicted and other stuff. So, So the Big Bang Theory is a pretty well established theory.
I do want to also mention that it isn't yes, you do still hear it referred to as the Big Bang Theory or the Big Bang model, but it's more frequently now, at least than it was in the past, that we have the lambda CDM model, lambda representing the cosmological constant, which is the accelerated expansion of space-time as a result of dark energy, and the CDM stands for cold dark matter. So it's essentially a modification of the Big Bang model that incorporates both dark matter and dark energy into it.
Right. And so anyway, let's continue.
Well, it's evidence for a Big Bang. I've said, why?
Hold on. We have a question from Drace. Are you referring, when you say 1 to 50K, I'm assuming you're referring to Kelvin, the temperature of the cosmic microwave background. Yes, it is in that range, closer to the 1. It's 2.73 degrees Kelvin.
Yep. And there was a question for everyone to see. So yeah.
It was a very wide range, but
yeah,
he didn't have much to go on at the time, so.
Yeah, but it's pretty much close to absolute zero as you can get.
Mm-hmm. Yeah, the cosmic microwave background is why no part of space-time right now can be at absolute zero.
Yeah, and also...
Go ahead.
Yeah, and also he just said why. Is that the case? Well, because the cosmic microwave background was predicted by the Big Bang Theory decades before it was discovered. So that is the answer to Dr. Lyle's question.
When a model makes a novel testable prediction that is then later confirmed, that is strong evidence for that model, especially when it's numerous predictions that end up being confirmed.
Let's try and list all of the predictions made by the Big Bang Theory.
The expansion of space-time, the cosmic microwave background, the abundance of hydrogen in the early universe are really the 3 big ones. There's some other ones I can't think of right off the top of my head, but those were the 3 big ones, all of which were confirmed.
Yep. So let's continue.
The cosmic microwave background, by way of explanation, if you could see microwaves, you could go outside at night and the sky would be glowing faintly with microwaves coming from apparently all directions in space. Now, secularists assert that's leftover radiation from the Big Bang. But how do you know that that's leftover?
I already answered how.
How do we know? Easy, because it was predicted by the model decades before it was observed. And it's like, how do we know that the gravitational waves were part of Einstein's relativity? Well, because we predicted it.
Yep.
Exactly. It's nonsense. And of course, he knows this. He knows that the cosmic microwave background was predicted by the Big Bang Theory. He knows this. He's flat out lying.
He's just pandering to his audience that he knows doesn't have the technical knowledge to know how he's wrong or why.
Yeah, exactly.
Radiation from the Big Bang. You don't know that. All we know about it for sure is that it's there in terms of.
I also want to point out that if Dr. Lyle wants to argue that the cosmic microwave background is not from the Big Bang, then he needs to make a model and say, what is the cosmic microwave background? What is it that we are seeing? How does his model explains this data that we are seeing? And his model simply, what was that?
He needs to provide an explanation for why those photons were emitted and what emitted them.
Yeah, exactly. And again, we should always prefer the theory that actually predicted it before it was found.
Where it came from, we don't really know. Now, I don't have a specific creationist explanation for it either, but.
Okay, so he's pretty much admitting that the creationist model has no answer for it.
We don't have an answer for it, but we know you're wrong.
Yeah. The answer is it's a leftover from the Big Bang. How do we know? Well, easy, because our model predicted it, and his model obviously did not, and his model cannot explain it, but our model can. We win. We got the model. We win.
That doesn't automatically mean the secular explanation is right. The fact is the universe has an average temperature. It is glowing. and that glow appears to be coming from all directions in space, but that doesn't mean it's leftover radiation from the Big Bang. It could be, I don't know, it could be the original light that God created and used for the first 3 days, and maybe he stretched it out.
More appealing to God magic.
Yep. And as I pointed out last night, the stretched out is more of a poetic language, so and not a literal language that is used in the Bible. But again, God's stretching it out, the original lights. But how do we test? How do we confirm that? We can't. It's a non-fossilizable answer.
And then it became redshifted to the point, where it's, I mean, I don't know. The interesting thing about the cosmic microwave background is it doesn't really have much in the way of spectral lines in it, except for those that have been imprinted on it by intervening material.
I laughed when I first heard this. So, for those who don't know, spectral lines are if you've ever seen a spectral graph, there's the little black lines that you see, and those are the minute frequencies of light that are absorbed by the electron clouds of the atoms of whatever particular material the emission source, like say a star, is made of. This is how we can determine the composition of stars, by looking for those black lines and where they're at, and we can say, oh, it's mainly hydrogen, or it's mainly helium, or no, it's got a little bit of carbon, or we got some oxygen, things like that.
Yeah, and by the way, that's how helium was actually
microwave background was not emitted in that manner, so it doesn't have spectral lines. For fuck's sake, Dr. Lyle, you know this. Oh shit! This is just more lying for Jesus.
Yeah.
When I first heard that, I died laughing. I was like, "Oh my god!" Please,
yeah,
he didn't just say this.
Yeah,
holy shit!
Yeah, I kind of want to replay it just so just for the laugh factor.
It is glowing, and that glow appears to be coming from all directions in space, but that doesn't mean it's leftover radiation from the Big Bang. It could be, I don't know, it could be the original light that God created and used for the first 3 days, and maybe he stretched it out, and then it became redshifted to the point, where it's, I mean, I don't know. The interesting thing about the cosmic microwave background is it doesn't really have much in the way of spectral lines in it, except for those that have been imprinted on it by intervening material. And that's interesting because all natural sources of light have an imprint on them of the atoms that made them. That's how we know what stars are made of. We break the light down from the star, and it's missing certain frequencies.
Did you notice how he really struggled to explain, at least from his model, because he doesn't really have one, what the cosmic microwave background is and why it's there? And then he's saying, well, I mean, it doesn't have spectral lines in it, so, I mean, magic could have made it, This is so ridiculous. Oh, my God. Oh, my God.
Like, we would not expect to find these spectral lines in the cosmic microwave background. That would actually be a pretty solid piece of evidence against it.
Mm-hmm.
So, yeah. And of course, Dr. Lyle knows this. He's lying flat out.
Yeah.
Of light are missing, and that tells us the substance that created that light. It's kind of an atomic fingerprint, and the cosmic microwave background seems to lack that atomic fingerprint, almost as if it was supernaturally created. So,
supernaturally created. I'm gonna do a
magic
double face palm. Yeah. But let's continue.
A Creo debunk also makes a good point. It doesn't have spectral lines because it is a black body radiation. That is correct. If I am thinking correctly, black body radiation does not have spectral lines in it because of the way that it is emitted. And here comes George Bond throwing out the vitriolic insults while offering nothing substantive because he's too fucking stupid to make a cogent argument to present. I think it's just funny.
Oh God, keep those insults coming. We love them. That's what we live off of. Anyway, let's continue.
Before we
I think
continue,
that's
it's also important to mention out that they're like, well, this guy's a PhD. He knows what he's talking about. Yeah, well, Richard Dawkins is a PhD in evolutionary. Oh, well, that's just an argument from authority. You can't cite him even though he's a PhD. The hypocrisy, it's ironic, but it's unironic because they're being serious about it. Like, oh, they have no problem saying, well, this guy's a PhD. He knows what he's talking about when it supports their point. But when all the PhDs that are against them are PhDs, oh, well, that's just an appeal to authority, yada, yada, rama, rama, ding dong. It's so fucking funny. I can't. Oh, fucking creationists, you guys crack me up.
kind of interesting. We don't even know it's a background. It might be relatively nearby. We don't know that.
Background me. It's all over. Yes, it is.
Oh God.
Oh my God.
Yeah,
Oh,
my
this
favorite
is a
background.
comedy show at this point.
Like how would it be local anyway?
It's a background. How is it local? It's like, oh God, holy shit, dude. He's just fucking lying. He's lying through his fucking weaselly little teeth. This is so fucking funny.
Yeah, exactly. And Dr. Lyle has to know this. He is a fucking PhD astrophysicist. He knows this. He's lying to the creationist audience.
But it doesn't prove a Big Bang. It doesn't, and it certainly doesn't prove billions of years because we don't know where it started from. And in any case, if you accept my explanation of this to Starlight, that'll work on cosmic microwaves as well. They can get here instantly using the anisotropic synchrony convention.
Awesome. Perfect answer. I appreciate that. Maybe this helps clear it up. Vitalis said entropic.
Entropic. Okay.
Autocorrect, I guess, messed that up.
Okay. So does light suffer entropy, I guess, would be the question. Well, everything suffers entropy. Entropy is a tendency of energy to go from a useful state to a less useful state. Things are winding down, so to speak. And that is something that the universe being closed in the sense, it's a closed system. I see what he's going at. The universe is a closed system in the sense that there's no energy allowed from outside the universe. If the universe is all that there is, there can't be energy from outside, accepting the secular view of it for the sake of hypothesis. So yes, everything would be subject to entropy, including light. And so, in fact, when light strikes a substance, it tends to heat up that substance, and then it can re-radiate, and it sometimes re-radiates in lower frequencies. Maybe you get 2 photons instead that are lower frequency, and that would be a higher entropy state. So light, like everything else, suffers the effects of entropy. And what that does is it shows us that the universe cannot be infinitely old, because there are critics who would say, well, we don't need God because whatever created the universe, you have to ask what created that. And I said, well, God's eternal. He has no beginning. So, well, the universe is eternal. I'd say it can't be because of entropy.
Anything you want to say to that, Leo? Oh. Hey, Leo, are you still there? I am going to give Leo some time to come back. I think he went out.
All right, I'm back.
Okay, awesome. Okay, so did you hear what he just said?
No,
okay, basically, just to run down here is talking about yada yada yada, second law of thermodynamics, and that proves that the universe cannot be infinitely old. And
that's not true.
Okay, yeah. So why don't I replay what he said for you to hear it?
The substance that created that light. It's kind of an atomic fingerprint, and the cosmic microwave background seems to lack that. atomic figure grid, almost as if it was supernaturally created. So I think that's kind of interesting. We don't even know it's a background. It might be relatively nearby. We don't know that. But it doesn't prove a Big Bang. It doesn't, and it certainly doesn't prove billions of years, because we don't know where it started from. And in any case, if you accept my explanation of this to Starlight, that'll work on cosmic microwaves as well. They can get here instantly using the anisotropic synchrony convention.
Awesome. Perfect answer. I appreciate that. Maybe this helps clear it up. Vitalis said entropic.
Entropic. Okay.
Autocorrect, I guess, messed that up.
Okay. So does light suffer entropy, I guess, would be the question. Well, everything suffers entropy. Entropy is a tendency of energy to go from a useful state to a less useful state. Things are winding down, so to speak. And that is something that the universe being closed in the sense, it's a closed system. I see what he's going at. The universe is a closed system in the sense that there's no energy allowed from outside the universe. If the universe is all that there can't be energy from outside, accepting the secular view of it for the sake of hypothesis. So yes, everything would be subject to entropy, including light. And so, in fact, when light strikes a substance, it tends to heat up that substance, and then it can re-radiate, and it sometimes re-radiates in lower frequencies. Maybe you get 2 photons instead that are lower frequency, and that would be a higher entropy state. So light, like everything else, suffers the effects of entropy. And what that does is it shows us that the universe cannot be infinitely old, because there are critics who would say, well, we don't need God because whatever created the universe, you have to ask what created that. And I said, well, God's eternal. He has no beginning. So, well, the universe is eternal. I'd say it can't be because of entropy. The universe is an energy system that's winding down. God isn't. God's eternal. The universe is not eternal. Can't be because it's suffering the effects of entropy.
So I don't think that the universe extends infinitely into the past, but there are models where that works, because we don't exactly know fully how thermodynamics works at the quantum level of reality. And even when the universe hits thermodynamic equilibrium, the vacuum fields of quantum mechanics will still be fluctuating. So they will still have energy. So obviously thermodynamics, especially the second law, doesn't work quite the way it does on the quantum level of reality. And we know that the very early universe would have been quantum mechanical. Most cosmologists, I don't think, from the last time that I have checked, most of them don't really think that the universe probably does extend infinitely into the past, but it is physically possible. There are models that could be true where it does. So that's not a problem for physics.
Yeah, and this is basically a rehash of the old Kalam cosmological argument that William Lane Craig uses on a regular basis. That being said, an absolute philosophical nothing, pretty much total vacuum with no particles or anything like that, is pretty much impossible to exist. And of course, we do know quantum fluctuations happen all the time, so the universe could be a quantum fluctuation. But of course, any thoughts on that, Leo? Leo, are you still there? Can you hear me all right?
Yeah.
Okay, good. Actually, William Lane, Dr. Sean Carroll, I think, did a really good job responding to that point in his debates.
Yeah, I mean the model that he presented.
Yeah.
And he even argued it was a hypothetical model. We don't know if it's true or not, but the universe extends infinitely in the past. So. Yeah.
I'm just gonna read a little bit of, I think, just real quick. So yeah, here we go. This is from Dr. Sean Carroll in his debate with William Lane Craig. So I think I can make these points basically by following Dr. Craig's organization, starting with the Kalam cosmological argument, and unlike what he said I should be doing, I want to challenge the first of his premises. After the universe began to exist, it has a transcendental cause. The problem with his premise is that it is false. There's almost no justification or explanation given for the premise in Dr. Craig's presentation. But there's a bigger problem with it, which is that it is not even false. The real problem is that there are not the right kind of vocabulary words to be using when discussing the fundamental physics of cosmology. This kind of first Aristotelian analysis and causation was cutting-edge stuff 2,500 years ago. Today, we know better. Our metaphysics must follow our physics. That's what the word metaphysics means. And in modern physics, you open a quantum field theory textbook or a general relativity textbooks, you will not find the word transcendent cause anywhere. What you do find are differential equations. This reflects the fact that the way physics is known to work these days is in terms of patterns of unbreakable rules, laws of nature. Given the world at one point in time, we will tell you what happens next. There is no need for any extra metaphysical baggage like transcendent causes on top of what is precisely wrong way to actually think about how the fundamental reality works. The question you should be asking is, what is the best model of the universe that science can come up with? By a model, I mean a formal mathematical system that purports to match one to what we observe. So if you want to know whether something is possible in cosmology or physics, you ask, can I build a model? Can I build a model where the universe had a beginning, but did not have a cause? The answer is yes, you can. It's been done 30 years ago, very famously. Stephen Hawking and Jim Hartle presented the no-boundary quantum cosmology model. The point about this model is not that it is the right model. I don't think that we are anywhere near the right model yet. The point is that it is completely self-contained. It's an entire history of the universe that does not rely on anything outside it. It's just like that. The demand for more than a complete and consistent model that fits the data is a relic of a pre-scientific view of the world. My claim here is that if you had a perfect cosmological model that accounted for the data, you would go home and declare yourself having been victorious. You might also ask, could the universe be eternal, since Dr. Craig talks about this view, without having a beginning at all? Again, the answer is yes, just build a model. This is my favorite model. It's not even a model that I think is the right one. Once again, it's a model I helped create. But it's about the search for models, not about seeing any one model is the right idea. We hope that someday we get there, but we do not claim that we are there yet. So whether or not the universe could be eternal does not come down to a convention of a conversation about abstract principles. It comes down to a conversation about building models and seeing which one provides the best account for what we see the universe to be doing. So I'd like to talk. Dr. Brink brings up an argument about the second law of thermodynamics, and I've written a whole book. You can buy it on Amazon right now about the second law and its relationship to cosmology. It is certainly a true issue that we don't know why the early universe had low entropy, and entropy has ever been increasing. That's a good challenge for cosmology. So again, a God of the gaps fallacy. So again, I think Sean Carroll did a really good job in that debate.
I need to ask George Bond a quick question in the chat. Who proposed that nothing created everything? And like Sean Carroll said in the quote that David just read, that's entirely the wrong language to be using. When we say that nothing created the universe, we don't mean that there was a thing called nothing and it did the creation. We mean that there wasn't any creation at all, and thereby there wasn't anything to do it. So you don't know what you're going on about. This is the problem with creationists, like Dr. Carroll was pointing out there, and it's very, very, very subtle. But he is essentially saying this is what's wrong with creationists, like William Lane Craig and many others. They don't know the math and they don't know the subject, and they want to posit all these philosophical, metaphysical, supernatural, transcendent stuff to do things when they don't have a model that describes that. They don't have any math that shows that that could be the case or how it could occur. Give us a model and we can work.
Yeah, and of course, as we were discussing
and I am still listening, but I gotta shut my camera off for a quick second.
Okay, sure. So we have the two models, the Einstein Synchrony model and the ASC model that Dr. Lyle is proposing. We have two different models. Which one should we prefer? Well, the one that makes the most testable predictions and the one that is most simple. And here, the ASC model is far more complex, far more convoluted than the Einstein model. So yeah, the ASC model is simply not a good model, especially since it cannot be falsified.
Exactly. And that's one of the things. This is how you know the difference between, and I'll get my camera on here in just a quick second. This is one of the things that helps to differentiate between a creationist and an actual scientist, even if that creationist has legitimate credentials, as Dr. Jason Lisle does, is that creationists will say, well, we can't falsify this model. Ha ha, you can't ever prove me wrong. I'm justified in believing this.
Yeah,
Whereas a
exactly.
scientist will go, I can't falsify this model. Well, then I can't ever, if there isn't a standard of falsifiability, I can't ever show that it could be the case, because there's always something that says that it can't be the case. If I ever show something that it can't be the case, then there's always something that shows that, well, no, it actually could be, and thus it isn't actually a model. It doesn't actually explain anything.
Right, exactly. And Anthony Silvestro's demonstrated so beautifully in our live chat that he has no model. He has no falsifiable framework. He has no falsifiable model.
Yeah.
We basically go back to Occam's razor. Who has the better model?
Yep.
So let's continue.
Awesome. And when you were saying earlier that if you were to look up and able to see radiation, would that be similar to like the aurora borealis? Would people be able to see that everywhere? Because that's radiation, right? Or
yeah, it would look different than that. The aurora tend to be concentrated. The aurora are beautiful. I don't know if I've seen them 3 or 4 times in my life. They rarely get down this far, but occasionally they do. Right. And they look like ribbons, and they move and everything. With the cosmic microwave background, it would be almost uniform. It would be kind of the same everywhere, the same color, the same, because it's the same temperature everywhere. So, but it would be something that, yeah, if we could see microwaves, you could see it anywhere on Earth at night. You could look up and the sky would be glowing faintly with these microwaves. And it used to be back when we had the old televisions that got signals over the air that were not digital. And if you turn to a station that doesn't exist and you get all this static on your screen, a small fraction of that is the cosmic microwave background. Interestingly, your old television can pick it up.
That's cool. That's incredible. I heard ants in a microwave do the same thing. They can actually see the radiation and they move away from it.
What's that?
I heard that ants, when they're placed inside of a microwave, can dodge the radiation. They can actually see it, and they move around it in batches, so they can't.
I haven't heard that, but that's interesting.
Yeah, but the next question was, what are some of the major problems with the Big Bang Theory? Because I'm sure you hear them all the time.
Yeah, the Big Bang, it's not really much of a theory. I guess you could call it a model, because it doesn't really make testable predictions about the universe, at least that have been specific and successful.
So we've already talked about 2, but 3,
is
most notably, the abundance of hydrogen in the early universe, which was confirmed by the existence of the cosmic microwave background, which was also a prediction that it made that was confirmed, as was the expansion of space-time, which has been confirmed.
Yeah,
so he again is lying through his weaselly little fucking teeth.
Yeah, this is a lie. This is what you learn in freshman. This is literally first semester basic stuff about the Big Bang Theory.
Literally.
I mean, there's no testable predictions. Come on, that is a flat-out lie. I already pointed out the cosmic microwave background was a direct prediction of the Big Bang Theory, and it was made decades before its actual discovery. Let's see here. A leftover glow like no other for neutrinos. Let's see here. I'm just going to look something up real quick. Read this real quick. Yeah, so the CNB I think is also a great prediction. See here. The cosmic neutrino background I think was also predicted, correct?
What's up? Sorry, I was responding.
I said the cosmic neutrino background is also one of the predictions made by the Big Bang Theory.
I don't know if we've observed that yet, but it is a prediction that was made. I would have to look at that again, actually.
Yeah. Actually, from 2019, earliest signals ever scientists find relative neutrinos. So it looks like that cosmic neutrinos detect. Here we go. Let's see here. Cosmic neutrinos detected, confirming the Big Bang's last great prediction.
Buddy, what are you doing, Cat?
Yeah.
So big guy right here.
Yeah. So he made the claim that there's no testable predictions. That is flat out false. That is a lie. He is lying through his teeth. This is flat out
And by
But,
the way, for the audience, we're charging him with lying rather than ignorance because he's a PhD astrophysicist. He knows what he's saying is not true, and he's saying it anyway, willingly, with the knowledge that it isn't true. That is
Yeah.
lying.
Yeah.
I'm kind of curious to know what else he's going to say about the Big Bang, but
Yeah. Did you watch this part yet or no?
no, this was actually like right about the part where I went to go shave and take a shower. By the time I got done with everything, he was
Yeah.
All
right.
it was over actually.
Yeah. Let's continue.
Successful. Some people think that the Big Bang predicted the cosmic microwave background. I'll sort of grant that, but
So again, he's sort of granting one of the predictions that was made by the Big Bang. That does not compute. That is a contradiction. He just contradicted himself.
What did he say? I'm
He
sorry,
said-
I'm responding to somebody.
Okay, so he basically said they would say that he basically said that he'll sort of give the cosmic microwave background was a prediction. He said I'll sort of grant that argument. So
Okay.
the cosmic microwave background, I'll sort of grant that, but it wasn't a very specific prediction because the temperature that it predicted went from 1 degree Kelvin to 50 degree Kelvins, and the true
And it
answer
was within that range. So, I mean, it was in the range that was predicted. I mean, the range can be big, but it was in the range. I mean, I don't know what you want, buddy.
Is in the right ballpark, but there was, it's like predicting that something will happen tomorrow, and then something happens tomorrow, and you say, "See, that's evidence for my."
Well, no, it'd be more like predicting that. Well, I predict that my mother is coming in for Thanksgiving. I predict that she'll be here somewhere between noon and 6:00 p.m. Pretty big range. We can make it even bigger, between 9 a.m. and 6 p.m. She gets there at 3:00 p.m. Well, that's in between. That's in the range. So you technically were correct in that prediction. Would you not be? Of course you would be.
Maybe not so much. It doesn't make specific testable predictions that have been vindicated. And in fact, it predicted variations in the cosmic microwave background that are orders of magnitude larger than what we actually see. So it didn't even predict the right kind of microwave background. So it doesn't make good, successful predictions. It's remarkably complicated in terms of all the band-aids they've had to add to it.
What band-aids?
Yeah, I guess he's going to talk about like the grand unified theory and inflation and all that. But let's see what he says.
Get it to be consistent, at least somewhat, with the observable universe, like inflation. If you've heard of inflationary Big Bang, that's a patch to try and explain why we don't have monopoles and why the universe has a sort of what we call a flat topology to it. But the Big Bang didn't predict any of those things.
What did he just say? I need to just put my fucking phone down.
Yeah,
Stop responding
I'll
to people.
replay. I'll go back. I'll replay it.
Inflationary Big Bang, that's a patch to try and explain why we don't have monopoles and why the universe has a sort of what we call a flat topology to it. But the Big Bang didn't predict any of those things. So it doesn't make good. It's not a good theory at all. It's at best a hypothesis. And
No,
in terms
it's
of
not.
problems,
And the magnetic monopole problem, the flatness problem, the horizon problem, the homogeneity problem, the isotropy problem are all explained by inflation.
Right, and the inflation is not just a rescue device because it does make novel predictions by itself. Correct?
Mhm. It's sort of. I mean, the predictions would be that the universe would be flat, and it is flat. That it would have inflated the universe and separated all the magnetic monopoles. That they would have decayed before we could observe them, and we don't observe any magnetic monopoles. That the universe would be homogeneous and isotropic. That it would look the same in every direction and would seemingly look the same no matter which. That it looks the same on large scales, and then it also looks the same pretty much in any direction that you look.
Yeah.
All those. And it fits so it explains problems that we have very, very well. And
Yeah.
it fits it. There's practically no required modification of the math other than the addition of inflation. Putting it into the math is the only modification we need to make to the pre-existing math. So it fits very, very well within the mathematical framework.
Exactly.
In fact, the best way to put it is it has all the marks of an accurate theoretical framework other than the observational, the observation of it, or the experimental data demonstrating it.
Problems, it's got all kinds of problems with it. One that I like to mention just because it's easy to understand, it's called the baryon asymmetry problem, or the baryon number problem. And basically the way you remember this is you ask the question, where's the antimatter? We can make
There's actually a mechanism
matter
for that
on Earth from energy.
The baryon asymmetry problem is asking why is there so little antimatter in our universe compared to matter? They should have been created in equal amounts at the Big Bang, or should have been developed rather in equal amounts in the early universe, but we were left with like vast majority of matter and practically no antimatter. Why is that? The running hypothesis that is quite viable for why this is the case is neutrino oscillations and the discrepancies in them between neutrinos and antineutrinos that paved the way for the dominance of matter over antimatter. Good night.
Energy. We can't make matter from nothing. Only God can do that. But we can take energy from collisions of particles at extremely high speeds, close to the speed of light in particle accelerators, and from that energy we can create new particles. But every time you do that, you also get an antiparticle. So if you make an electron, you'll also make a positron, an anti-electron, which is the same as electron, but the charges of the particles are reversed. And so according to the Big Bang, the entire universe was originally energy, and then as it cooled, it became some of that energy became matter. But the problem is, according to everything we know about physics, you should get an exactly equal amount of antimatter. But when we look out into the universe, we find it's essentially matter only. There's only trace amounts of antimatter anywhere in the universe, and they're always produced locally anyway and almost immediately destroyed, because when matter and antimatter touch, they tend to annihilate each other and release energy, especially in the form of photons. But so the fact that our universe is matter only indicates that it was created not by a natural process, but by a supernatural process, because every natural process.
There's nothing that indicates anything supernatural or non-natural has ever occurred or ever will occur or is occurring in reality. There's only spurious and dubious and oftentimes oft-refuted claims that have never been supported, that we've looked to support, we've actively tried to support, that we have isolated variables in experiments to try to support, and have all come back inconclusive. All of them, literally all of them.
That converts energy into matter also produces an equal amount of antimatter. And that
I'm
problem
still
has
listening,
not
but
been
I'm going to move again.
solved in the secular worldview. I mean, there are proposals for it. The latest idea is that, well, every now and then, one time out of a quintillion, when energy becomes matter, there's no antimatter produced. It's matter only. So but that hasn't been observed. That's just a rescuing device. It's not something that has experimental support. So that's one example. There are many others. There's the flatness problem and the monopole problem, and inflation attempts to solve at least some of those, but it doesn't solve all of them.
Yes, it does. It literally does.
You're touching on all the best points here. I read about the antimatter problem.
Yeah, no, inflationary theory literally explains all of it. That's why it's, despite the fact that it has no experimental or observational confirmation, that the overwhelmingly vast majority of cosmologists accept it.
I believe it was in your Taking Back Astronomy book. So great answer there. And you also mentioned inflation. Is this the rescue device essentially for what's known as the horizon problem?
That's right. The horizon problem is a light travel time problem that the secular Big Bang, as it originally was proposed, had. And basically the problem is these microwaves, which secularists assume are the leftover radiation from the Big Bang. Well, microwaves, the frequency of those microwaves tells you something about the temperature of their source. And as I mentioned earlier, that microwave background is very uniform. What that means is the source temperature of everything in the universe was originally identical, or very nearly so. The fluctuations are very tiny. And yet in the Big Bang model, when the universe is supposed to have popped into existence there's a singularity where all of space is contained in a point, and then it rapidly expands out like a balloon. The surface of the balloon represents the 3 dimensions of our space, and there should be hot spots and cold spots. That's just due to the Heisenberg uncertainty principle. You would have to have, because of the small scale, you'd have to have places that are hot, places that have a lot of energy, places that are cool, places that have less energy. The universe rapidly expands out, carrying the hot spots and cold spots far away from each other. But wait a minute, they're all lukewarm now. Okay, all those temperatures have evened out, and yet there hasn't been enough time for light to travel, and therefore energy to travel from the hot spot to the cold spot to even out those temperatures. Right? I mean, if the hot and cold were in contact with each other, they would eventually come to the same temperature, because heat tends to go from hot to cold. That's the second law of thermodynamics. And so you put your ice cube in your hot coffee.
But wait, if light can travel instantaneously, then couldn't it just travel from one side of the universe to the other instantaneously, Dr. Lyle, on your model?
Yeah,
it's interesting that she brings it up. And he's really butchering, and I understand he's talking to a lay audience, so I'm not going to give him shit for it, but he's kind of butchering. So the horizon problem essentially states that very, very distant parts of the universe seem to look the same, despite the fact that there wasn't enough time for the light to travel there, because the light travels at a defined speed. We fucking know this. For it to essentially communicate to look the same. And inflation does solve that by stating that the universe rapidly inflated, and that's why. And it's not a rescue device at all. That's why the vast majority of cosmologists accept it. It fits well with the math. It explains the problems. It literally has all the marks of a theoretical framework other than experimental or direct observation.
Yep. All right.
Coffee. Eventually, you'll end up with lukewarm coffee. They come to the same temperature. But they have to be in contact. They have to be able to exchange energy. And there hasn't been enough time, even if you give them the 13.8 billion years, there hasn't been enough time for light to travel from that hot spot to that cold spot, because they could be on opposite sides of the visible universe. And so the inflation is an attempt to solve that problem, along with the flatness problem and perhaps the monopole problem. But the idea of inflation is that the universe started expanding at what we'll call the slow rate, although it's actually very fast. And then it suddenly ballooned out at a much faster rate. And then that inflation phase, that's the inflation phase. And then that switched off and it went back to the slow rate again. And so the idea is that the hot spots and cold spots could have evened each other out right before this inflation phase pushed them far apart. And I'll grant that could reduce, maybe even solve the horizon problem, but it introduces other problems of its own, such as what would cause the universe to suddenly expand at a much greater rate.
I can explain that.
There are hypotheses as to, some kind of symmetry breaking in the laws of physics. And then you got to add.
The leading mechanism for inflation is that essentially all quantum fields under a grand unified theory would have been combined into a grand unified field, where the particle of that field was called an inflaton. It would have been called the inflaton field. And as the particles began to decay, they created into the normal matter particles as this field lost energy, and as like you said, the breaking of the symmetries in the unified field theory, those symmetries began to break, the forces began to separate, the matter particles, the inflatons began to decay into the typical elementary particles we see today. This process created an extraordinarily gravitationally repulsive force that drove the universe apart uniformly, and we call that inflation. So yes, there is a mechanism for this. Now, this, I don't know if he actually knows, because, well, it's really not new. I think inflation came about from Alan Guth and a couple others in, I think, the 80s. So, I mean, it's just more weaselly lying through his weaselly little fucking teeth.
Yep. And I would pay big money to see Dr. Lyle debate someone like Dr. Craig or Dr. Krauss or any of the other big astrophysicists.
Yeah. I think you meant Dr. Carroll because you said Dr. Craig, which I would like to see him debate Dr. William Lane Craig, because the people like Lyle think that people like Frank Turek and William Lane Craig are heretics because they accept that the universe is billions years old. They accept the Big Bang, all that stuff. But I did want to let you know I've only got about another 12 minutes until about 11:30, and then I got to start wrapping things up.
All right. Yeah, this is definitely a long stream, so maybe we could do part 2 either tomorrow or Friday.
Sounds good.
All right, let's continue.
Ask what would it cause it? How would it stop everywhere? And how would it know to stop everywhere at the same time? That is a huge problem
because the field stopped decaying. The inflaton field stopped decaying, so space-time stopped inflating. I mean, Yeah, this isn't hard, buddy. You're the PhD. You should know this.
There are still small temperature differences. Even today, there are small temperature differences. And so if it's some kind of symmetry breaking, you would think it would turn off different places at different times, but it didn't.
No, that's
You have
not how
kind of a
symmetry breaking works. That's just literally not how symmetry breaking works. Take a quantum field theory course, guy.
Uniform universe, and so that's called the graceful exit problem. So the horizon problem, inflation, an attempt to solve the horizon problem, and then the graceful exit problem is a problem with inflation. And some secularists reject inflation entirely because they realize it has its own issues, and they've proposed alternative solutions.
Very small amount of astrophysicists and cosmologists reject it. A very small amount. That is how well within the current framework that we have that inflation fits. That it's an extremely small number of cosmologists. I can probably, I mean, I can't remember all their names, but out of the names that I've heard, I could probably think of maybe 6 right off the top of my head. That's not a lot at all.
Horizon problem, but I think inflation is still the most commonly accepted secular solution to a problem. But as I said, it's got problems of its own.
Wow, great answer. So they say we have a light travel time problem when in fact they're the ones with a massive light travel time problem. And then based on what you said, in order for them to solve that problem, it turns into a ripple effect of other hard to solve problems. And you pointed out that some authorities on the subject even reject inflationary theory for that reason. That's
yep. And I'll point out too, just in case anybody's wondering, that the Anisotropic Synchrony convention solved their horizon problem. The answer is no, because they need to get the speed of light both ways to be much faster than it really is. Because it's not just the hot spots here that have to get information, have to dump energy to the cold spot there, but it's also a hot spot here that has to dump energy to a cold spot over there. So
yeah,
it
but
has
wait, couldn't it be going one way from here to here, and then this side going one way from here to here? So, like, I'm sorry, but you're trying to wiggle your way out of admitting that your model has to solve that or should solve this, but it doesn't, because you want this to still be a problem. This guy is so fucking weaselly. He's so weaselly. I mean, look at his weaselly little face. He's such a fucking weasel.
Be faster in both ways, and the Anisotropic Synchrony convention, you can only have light. You can only have light instant in one particular direction relative to an observer. Now, it could be the incoming direction, regardless of what that is.
Right.
So north to south if it's this way, and south to north if it's that way. But you can't have it then going out in that same direction be also instant. So synchrony conventions will not solve the horizon problem. But we have an answer for our Starlight problem that is consistent with known physics.
Is he going to say God magic? I bet he'll say God magic, which is not consistent with physics.
And the secularists really don't.
Wow, that's awesome. Great point there.
Oh, he didn't say God magic. I was surprised.
So here's the question I have. I'm not quite sure. Maybe he's saying, because still the light from here gets point here instantaneously. So light rushing from here should get here instantaneously.
Yeah,
it shouldn't matter about it should not matter what the where the observer is, because
on the ASC, any light from any point going one way to another point should get to any other point instantaneously, regardless of its distance. These are the inconsistencies with the ASC.
Right, because he's pretending like, because we have just 2 points of stars here and here. Both of them should be sending their light towards each other instantaneously, regardless of their round trip speed of light, correct?
Yep.
That's what it should be.
And a couple of questions came in pertaining to that answer. Let me see here. Guys, great questions in the chat, very lively chat. I'll never be able to get to all these, so let me at least pick a couple out. Super chat here from Jamie Russell. Thank you, Jamie. Can you explain how the universe doesn't have a center or could be infinite if we started as a point in Big Bang cosmology?
Yeah, the entertaining for the sake of argument, the Big Bang idea that the universe started from a point which expands like a balloon, the surface of the balloon, which is two-dimensional.
No, that's not what the Big Bang says. The universe doesn't expand like a balloon.
I think he's.
Oh my God.
I'm gonna.
And this comes down to the math. Like, and I understand that these are,
I think I understand what he's doing. I don't think he's lying here. I think he's just trying to dumb it down
Yeah,
to the
yeah.
layman audience. I'm not going to call this a lie, but it's not quite how it works.
Yeah. And the reason that the universe doesn't have a center is because the expansion of space-time is metric. So
Yep.
any observer would observe is not good. The space-time immediate around them isn't going to be expanding, but the further out you go from in any direction from that observer, the universe is going to be expanding. So you could be here and the universe is going to be expanding. You could be over here. You could be over here. It doesn't matter where you go from where you're at. It's going to look like the universe is expanding outward from where you're at. It's always going to look like you're at the center of the universe because it's a metric expansion of its scale. And it doesn't have a center for that exact reason.
Yep.
You can't have a center. You can have a center in space, but space itself can't have a center. And since space itself expanded at the Big Bang, it doesn't have a center.
Dimensional is supposed to represent the three-dimensional nature of our universe. You can think about our universe, if you wish, you can think about it being wrapped around a fourth dimension that we can't perceive. And so just as the surface, there's no one point on the surface of a balloon that is the center, right? And so, I mean, there's no unique center. I mean, every ant's walking along the balloon, every one of them could say, I'm in the center, but so could every other ant. But they're actually on the surface of an expanding two-dimensional structure, whereas we apparently live in a three-dimensional structure that's expanding. If you want to think of it as being wrapped around a fourth dimension, you can do that, although it's not really necessary mathematically for that to be the case. So, even though I don't believe the universe started from a point, I do believe it's expanding. I think there's good evidence for that. And the balloon analogy, I think that works for a creationist universe too. It's just God created our balloon with size, and then he's blown it up a little bit since then. Our balloon was never a point. And so if that's the case, then there may be no unique center to our universe, or there could be a center. We don't really know. It could be that the galaxies end at some point. It could be that there are a finite number of galaxies in the universe, and that at some point there aren't any, and there's just space beyond that. It could be the case. It could be that our universe wraps around on itself. We don't really know.
Actually, we do know that the universe geometry is pretty much flat, so that's flat out wrong.
Mm-hmm.
So,
yeah, like I said, this guy's just weaselly. He's just weaselly.
Really know, but any of those are possibilities.
Right, great answer. Yeah, like I said before, this is such fascinating stuff. And let me see here. I'll grab this one. I'll definitely get the super chats, guys. So Jungle Jargon for $5 asks, could the vacuum of space be causing the redshift?
In a sense, that's actually the most common view, actually, because the idea is, when people think of redshift, they think of a Doppler effect a lot of times. Just the way the sound of a car's horn changes as it goes past you, it drops. Light will do that too. Light will shift toward the red. It's much harder to see with light because, well, for two reasons. For one, the speed's just unimaginable. Light is so much faster than anything else we experience. And secondly, our eyes are not analyzers. Our eyes are synthesizers. Our eyes combine wavelengths into a color experience, where our ears don't do that. Our ears can separate sounds into different frequencies. So if I hit two notes on a piano, you'll hear two notes. But if I shine two colors in a circle, you'll see one color. You'll see that combined. So there's a difference there. But with spectroscope, you can measure the shift of the spectral lines in these galaxies. And the farther away galaxies are, the more redshifted they are. And the initial explanation for that was, well, they're moving away from each other. But probably a better explanation is that you can think of them as being at rest on a universe that's actually expanding. And as the light travels through that expanding fabric of space, it gets stretched out. And so it's in the most popular view, which I think is probably right, that the redshifts are caused not by Doppler shifts, but by expansion of the universe, at least on a cosmic scale. The reason the distant galaxies are redshifted is because of the stretching of the fabric of space as light travels through them.
That is
and
correct.
So, the vacuum.
I just said that is correct.
The space probably is what's causing a lot of the redshifts, although motion will do it too.
Awesome. I appreciate that answer, Dr. Lyle, and thanks for the super chat, Jungle Jargon. A lot of people enjoying this. Thanks for the conversation. Very informative. So I've got Dr. Lyle's website in the description box, so please check that out for more information on this. This has been awesome, Dr. Lyle. My next question would be, I watched an interview with you not too long ago on craters, and I think it would be a good question and answer for my audience to hear. So I would ask, how best do we explain then craters according to the young biblical creation model?
I think this would be a good place to stop.
Well,
We can pick it up from here. Oh yeah, we're a little over halfway, about 3/5 the way through it. Not bad. Right about 2.5 hours. We've made it so far. That's not bad at all. You're muted, by the way.
Oh, I am so sorry. I didn't realize I was muted. So yeah, I think this is a pretty good place to stop also, since he's now talking about craters. When I pick this up tomorrow at around 9 o'clock, 10 o'clock?
In the morning?
Like at night.
Okay, yeah, I was going to say in the morning, probably not. I'll probably still be asleep.
Yeah, I'm going to my mom's house tomorrow morning for Thanksgiving dinner, but that's about it.
Yeah, I can pick that up in the... Yeah, that's no problem.
Yep. All right, I will see you sometime tomorrow. So yeah, join us tomorrow, 9 p.m. Eastern Time, 10 p.m. Eastern Time. Depends. Check. Make sure you check back in while we finish this thing up. So anyway, don't forget to hit like. Don't forget to hit subscribe. Don't forget to hit the bell notification down below. And see you guys here tomorrow. And Leo, and everyone, please go to Leo Felius's channel and subscribe to him as well. And Leo,
YouTube.
if you want, feel free to download this video and mirror it to your own channel if you want.
Right on. YouTube.com/.